This is really an epic journey of humanity, because for the first time in the history of mankind, we have the knowledge, both engineering, scientific, and business knowledge, to be able to start reaching to the stars for many of the things that human beings need to be effective and to be happy. And so to be on this journey and to be the activists, if you will, helping people understand what this can mean is just a joy. And that's why I'm so grateful to be a part of this.
And there are innovation patents that are waiting to come to market to create that next billion or trillion dollar economy. And we need to look for that workforce where we may have not thought of them, in the inner cities, in rural communities, minorities, women, veterans, retirees. We have the workforce we need for the space economy. We just have to reach out and let them know that they can be part of this community.
But we want for Mars Coin for it to be democratic, for anyone to be able to mine it. And so it's very easy to get a hold of one of these. This is called a Future Bit Apollo, Moonlander 2 USB key. But there's a wide variety of ASIC hardware that's available. And we're even talking about making our algorithm even easier so you can mine it on a smartphone or a computer.
Space and some other niche markets we found gave us the ability to make revenue, bring in some business, to show we can execute, to also mature manufacturing so we know what the yields look like and the stats.
There is a misunderstanding that just because we are talking about space is all about wonderful cooperation. That is what we aspire for and we hope for. But if you look at the programs, for example, China and Russia space program, Turkey, for example, India to an extent as well, these are very nationalistic space programs. Yeah. And so China, what it has very cleverly done is that it has actually established a Belt and Road Space Information Corridor in the last few years. And this is President Xi's thinking in terms of institutionalizing the Communist Party of China.
Andy talks about risk in a couple different ways. I've been...
That's my car. Go on.
Oh my God, that's epic. It's still wrong, but it's epic. Space Force TM, trademark for Netflix, I think is a damn funny show. Your character is played by John Malkovich. Like, that guy is you.
Who has a much better oratory style and a much better wardrobe than I do, by the way.
And to me, when we're ready to use a certain technology, a certain thing, not just for solving problems, but also for the expression of our very being and in who we are, I think that's one of the markers that technology has arrived. Like, it's now something that helps us talk about who we are, not just solve the problems we have.
The big moneymaker is probably in the near term going to be the backlog of space tourism that we're seeing. And so this is nothing to do with a government program. This is commercial companies making commercial, doing commerce in the private sector, which has been really looked down upon in the news, but I think it's kind of exciting.
This is our opportunity to build a future where we take this journey into the economy of space and do it responsibly as a human race.
I think we can get there, but I think we got to be smarter than we were in the past. And this is where we want to get to. This is what the next plaque needs to say instead of "we came in peace for all mankind." We came in profit for all mankind.
Good morning, y'all. Thanks for joining us today. This is an historic anniversary of the landing on the moon. Kind of a big deal to me. I'm sure it is to all the rest of y'all. And what's I think really neat is it's the first recognized International Moon Day recognized by the United Nations, and I think that's pretty terrific. There's a global celebration of humanity's first steps, and I think we're going to do a lot of other stuff in the future, but it's kind of amazing to me that it's been 53 years, and a lot of people, especially folks I know that are younger, don't really look at the moon the same way older folks look at it, which I think is really interesting. But I think that in the coming months, because some programs going to the moon are already on their way, in the coming months, in the coming years, as the next boot prints on the moon land, I think the conversation around the moon is going to change. And so I'm really, really looking forward to that. We have a pretty terrific day lined up for us. And then we also have another day on Saturday. So I'm going to talk a little bit about what our schedule looks like. And then I'm going to bring in the folks who kind of made this whole event possible. So we're going to talk with Celine Kennelly, which, by the way, I love that, she's interested in space and her name is Celine. We're going to talk with Terry Trevino about lunar analog sites. The chairman of the Moon Society is going to come in, Philip Kroom. He's going to talk about membership and the survey that he crafted yesterday. I thought it was pretty interesting. We're going to hear from, we're going to hear about a new set of books being developed by a publisher, Mercury Learning. I'm going to talk a little bit about the Starship Singularity and the grand architecture, how I think the future is going to unfold for us. Philip is going to come back and talk about some of the Moon Society's interests, where they hope to go and what they're doing now. Following that, we're going to talk with Laura Forsick about news, really focused on living on the moon. That's today's theme. That's our events theme today and Saturday. Past events, we've talked a lot about development and minerals and the regolith and things like that. But really, we're trying to figure out what's it take to actually live there. And then I'm super excited to have Dr. Andrew Aldrin to come in and talk about the government and the industry as risk-sharing partners. His talk is, I think, going to be especially cool because if you recognize the last name, he is the son of the second person to walk on the moon. And so I don't want him to be overshadowed by his father. Andrew's got great credentials in and of himself. He's a professor, was at Florida, now he's at Embry-Riddle. But just, what I asked him for was to do a compare contrast between the Apollo era and the new upcoming Artemis era. So I think that's going to be especially fun. And then Nicholas Jobstrat, Dr. Jobstrat, is going to be joining us for a special celebration to recognize the 53rd anniversary. So that's our program for the day. I'm going to post this in the chat in a moment, but that's what we're looking at. If I could have Philip, Dana, and Nicholas promoted to panelists. I'll bring them on for a moment. Fabio. what we're going to do over the next 2 days is kind of take a look at our history and heritage, and then use that as a starting point, and then start looking at the future. So I'm going to promote. And I'd really like to thank the Moon Society for building this program, for taking such an active role in it. This is now their third annual Lunar Development Conference, and it's been really terrific working with them over the last almost 10 weeks or so now. Philip, Dana, Nicholas, can you chime in here and talk about the Moon Society and your roles in it and what we're doing?
Hi, my name is Philip Kroom. I'm the chairman of the Moon Society. I want to thank everybody for coming up, for joining us here today. We look forward to having you all here, and we're celebrating the historic Apollo 11 moon landing 53 years ago today. And again, we want to celebrate that. But we also look to the future. The Moon Society we are looking forward to not taking that first step, but taking the second step. And, that second step, we see that as both economically developing the moon, using robots and using people. And eventually we look to settle the moon. And as I think we are all gathered here with the understanding that the moon is a critical linchpin in the future of space civilization. And we here at the Moon Society are looking to be looking to take a lead in that role. Thank you.
Cool, thanks. Nicholas, Dana, do you want to chat?
Okay, my name's Dana Carson.
Yeah, Dana, continue.
I've been involved with the Moon Society since it was created. This actually started off as the Artemis Project many years ago, where in a discussion online, we figured out that if you had sold commercials during the Apollo missions, you could have taken in enough, given the size of the audience, to cover the direct mission cost, not the whole cost of the program, because most of it's the R&D development, but the actual cost of the first flight directly was less than you could have sold the commercial time for. So we started thinking, nobody's ever looked at how do you make enough money short term for private space, and that would do it. So, and then ever since then, I've just been involved in this. No expertise particularly in it. I'm a now retired computer programmer, but I'm old enough that, and I watched the Apollo live. So over to you, Nicholas.
Yeah, well, I agree with what has been said so far. And for me, the main aim of Moon Society, but me being part of it, is to get people living on the moon. And I am trying to do my bit for that by trying to make a moon base analog in an old school building that I have bought for the purpose.
All right. Well, with that, thank you, folks, for joining us today, and for the board here. I'm thankful for being a part of this. Thank you very much. We're going to move on here in a moment with our first speaker. So I'm going to bring her on. I'm going to disconnect y'all. Let's see. I'm doing something wrong. Fabio, if you could cut Nicholas and Dana, that would be terrific. Thank you. I'm going to bring on Celine. Hi, Celine, can you hear me?
Hi, yeah, I can hear you.
Terrific. So Celine is an I'm not sure how to pronounce this, archaeobiologist, and she's going to talk about that because I need to learn that myself. Celine is an archaeobiologist combining archaeology and microbiology to investigate the origin of life. She is also a space communicator and director of the platform Space is for You. Her involvement with space continues with the Space Generation Advisory Council, and now she's an Italian national point of contact. Celine, thanks for joining us. I know you're going to talk about it further, but how does one combine archaeology and microbiology?
It started it wasn't planned. I always liked archaeology because when I was a kid, an archaeologist actually came into my backyard and found some megafauna bones. And since then, I was like, I'm going to be an archaeologist. And while in my undergrad, I understood that I wanted to investigate life itself. So that was brought me into my master's in molecular biology. And now what I'm doing, I'm combining them, trying to understand at a molecular level, but also looking at some geological record, how life could have come to form on Earth. And I mean, it's taken a long time for me to understand what to do when I grow up. And in the last few years, I started to be more involved with astrobiology and the space community. And I kind of carved my way into this field.
Great. I mean, I think that's really, really interesting. We had a speaker on another event about a week and a half ago that a love of cooking led to chemistry. Chemistry led to going to a lunar habitat. So I find that, or sorry, a Martian habitat. So I find it kind of amazing how we all got here. So I didn't really want to kind of derail your opening remarks, but I wanted to hear that story. So please go ahead. The screen is yours.
Yeah. To share it.
Yes, please.
It doesn't show me an option to share the screen.
Fabio, can you, let's see, I've given you permission to, you've got permission to talk. Let me. Fabio, can you promote her to co-host? I don't seem to have that power. Are you able to come on video?
Myself, not. It doesn't, I just have the option to mute and unmute myself.
Well, that's very curious. I am going to remove you for a moment and try to bring you back.
Okay.
Sorry, I hit the wrong button. That's my fault. And Dana, if you could pull yourself out, that would be helpful as well.
I think you should be able to see me as well.
Terrific. Thank you. Sorry, yeah. I must have hit the wrong button when I brought you.
Oh, good.
Okay.
So I think everyone should be able to see my screen now.
Yes, thank you.
Yeah. So yeah, what I'm gonna do today is actually talking about a project that it was my first project in space, kind of, and they pushed me to be more involved in this sector. And it started through the Space Generation Advisory Council. And actually, the project is DOMI Inter Astra, which is a moon base, and the interdisciplinary approach for cooperation to build a near future moon base. And DOMI Inter Astra means home among the stars. So actually this project, when we started through the Space Generation Advisory Council, because they put up a call to put a team together to compete for the 2021 Moon Society Moon-Based Design Contest. And it's quite bizarre because I was like, it's my first time doing something like this. They were also looking for project coordinators, and I sent my application as a team member, and I didn't apply as a coordinator, but then I was like, this could be like a really good platform for me to increase my communication skill, management skills, even if I never worked in the space sector before. And apply actually to be a coordinator, and I was selected to be the one. So since December 2020, that I'm leading this project together with other two co-coordinators now. And we won the Moon Society Space Design Contest, which we gave all of us, we spent 2 months working on it, weekly meetings with people coming from all over the world. And we knew it was good, our project, but we didn't know who we were competing against, to what to expect. And honestly, we were like shocked kind of when the winner was announced. And we were like so excited. And the point is, in just 2 months, we had so much research that was done and so much work that we wanted to do that could have contributed also the divulgation on why we need space, on why building a moon base with a multidisciplinary international approach. So we decided to keep on going further with this project and to take what we've done for the Moon Society competition and elaborate it a little bit more and create a book, a divulgation book for people that know nothing about space, or for people that are also in space. But this book, what we want to do is to have no scientific jargon at all. So it's for everyone, and that everyone can enjoy and see how by combining all these like multiple disciplines would be actually possible to have a moon base. And so this is our team. For me, it was quite challenging because you have people from all over the world, like Philippines, India, Asia, and coordinating with all of them over 1 year time. So we're all still working on the book, and we hope to publish it by December. I mean, it's challenging because all of us are also volunteer. So keeping up the enthusiasm, showing them that their work, it's important that they're going to be recognized for it. It's also challenging for everyone, because sometimes we don't see straight away that our effort are going somewhere. But just to give an overview of the interdisciplinary and international background of our team. So we have all of the nations that are present in our team. So we have almost every continent, and all of these are the backgrounds that all of our team members come from. So these give us really a view, especially when we put the call for team members, we wanted to make sure to have people from different backgrounds, not just engineering, management, or economics, but also medicine, different science disciplines, artists as well. Because this is what we're trying to build, is a home among the stars, but also to be self-sufficient and to try not make the same mistakes that we did here on Earth. So we really wanted to bring this interdisciplinary approach and show it to the public. And so how we went into developing our project is, first of all, we kind of had these thematic groups that initially is another challenge because we are all knowledgeable of our own discipline. The problem comes when engineers have to talk with doctors, for example, or psychologists, or architecture. So how are we going to make a base that is also pleasant to the eyes? Because the engineers, we saw that they wanted to be efficient. And then we went into the architects, they wanted to have it beautiful. But then there's also the psychological effect, how we're gonna make people love this place. Because one thing is, if you're there for 10 days, 1 month, but the base, when we were developing the base, it was developed for people to live there between 6 months and a year at the beginning. And so we have to put into consideration all of this, and also what kind of society is going to be formed inside the base. So to promote unity and people getting together to share each other's culture. So even like one thing that came up that it's still hard for us to understand is, what is our language? How are we going to communicate? Is everyone that's coming to the base going to know English? Or are we going to have more than one official language for our base? So it's really interesting to see like how each time that we thought we had an answer, like more questions came up, and we have to understand how to also answer those. And one thing, I'm going to go into the design in a moment, but one thing that was quite difficult and took us a lot of time is to understand the international cooperation. Who's going to be the management body of our base? Because we can have the technology, the engineering is going to be in place. We can have, the means that bring us there and back to Earth. But one of the biggest issues, it can still remain diplomacy. How are we going to all work together to build this base as the human species on the moon? So we're trying to see some examples that we could have bring from Earth, like the Antarctica, the bases in Antarctica, the UN model, and we also took into consideration the policies that were developed by another space generation group, which was the SJC Eagle, which they proposed a lunar governance charter that was also presented in Cobos. So we're trying to bring all of this together, because without this, we can have a base, we can have people coming and going, we can have food, but if we cannot cooperate, it's going to be problematic. We also thought, should we bring guns? What if people get into fight? So like the social aspect is actually, for me, was really interesting to see, and really difficult to actually come up with an answer even now. And so this is instead the economics kind of part, because we have all of these. How are we going to find this? So I wasn't part of the economic team, but they put a lot of work to understand how to kickstart raising fundings, and how in the long run our lunar base could be sustainable on its own without depending on Earth. And now we come to the models. So what we wanted to do is something that we can bring there, quite light, but able to protect us. And as well, that later in the years, we can connect with other models and expand. So this was our basic structure design of the modules. And this one instead is the overview, our blueprint of what we thought the initial base would look like. And we try to also include some space tourists over here. So this one here is our central model where people can socialize. It's one of the first modules that people will also see when they enter in the moon base. And instead here, we have the control center in this part. And here, instead, we have some hotel rooms because we want to share the moon with also the public and not just scientists or the politician or the managers that are gonna come there. So over here, they can see what's happening in the control room. And then here, we go into the social area. While this one here, it's our laboratories. So initially, we're just gonna we plan to have just this module that it's for any scientific purposes, whether it's biology or even engineering, geology. So everything is gonna happen here. And later on, when we progress with the years, we plan to expand and have different models specific for more, for different subjects, for different disciplines. Instead, over here, this is another core module because we're gonna have the kitchen. Like this is a kind of relaxing area. We wanted to have a green wall where people could meditate, reflect, do some yoga and so on, where they would be like on their own, because privacy we find is another important thing that affects us psychologically every day. And having to live here in just those 1, 2, 5 modules, it's not going to give you much privacy. So this is like for you, it's your time. And over here we have toilets, the gym, and here's the kitchen. And even this one is important because food for humans, for many cultures, is a way to share, not just how they went, but also share the hospitality, the culture, the history. So it's a really important moment to bond together. And at the end, we come here, and here we have the living quarters. So we have the bedrooms. And this space was put together with the aim to have around 30 people to live in here, which include the tourists. I'm going to present some renders now, because one thing that we wanted to promote, it was also the psychological effect, how architecture, psychology, and engineering could come together to make life on the moon base better. So how people could live in a long term on the moon without suffering that much from depression, or you're gonna still feel that detachment from Earth because you don't hear birds, you don't hear nature. So we also come up with ways to put speakers that could make sounds of the nature, of birds, of the sea. And we wanted to have it in each room so that people could go there and just have a time for themselves as well. And one thing that we wanted, it was to also have plants all over the base. So this one here that we see now is our co-working area. So it's the laboratories. And we kind of here took from the ISS to have modules here with the labs where we can do experiments. So people could also send us experiments that we can perform, kind of what astronauts do on the ISS today. And this one here is the bedroom. And again, lots of crane, as we try to always put. And this one here, so the lights, we wanted, so our base is white, because all over we want to put lights that are able to change color, for example, even mimic the sunset. and the sunrise and sunset. So to keep on going with this, with our cycle as well. And the room, we might have to work a little bit more on this because they're really compact, not much space. But again, we are the base was designed to be completed in the near future. So in the near future, we didn't see the much opportunity to have much space for the bedroom. So we kind of took the concept of RVs and tried to place everything in a compact place, but still able, still trying to make the people feel that it's a comfortable space where they can sleep, rest, and work. Over here, this is a communal area. Again, we have the white walls with the lights still be able to change during the day. And here it's our initial farm, where we, because at the beginning, of course, we cannot be self-sufficient. We still need to depend on Earth for food supplies. But this for us, it was kind of an initial step to make some experiments with plants, with vegetables, and to see how they grow in this environment. And one thing we heard from many astronauts, many people that went into orbit, is the overlook effect. And with this window, that's what we wanted to do. We wanted people to take the time, especially tourists, to go there and actually see Earth from the moon and to understand how does it change their perspective on Earth, on their life. Because the overlook effect is something that people are really studying now to understand what's happening, how people change their mindset and think, and even if before they were kind of looking at nation, these borders, once up there, they see no borders, they see us as a whole community. So can we transmit this by having people living in our moon base? And so after this, we kept going a little bit further, and some of our team members actually took part in architecture competitions later in 2021. And this is how, for this, we were, I don't remember exactly which year, but we were, I think, 20 years into the future from where we first started to build the base. And this is how we developed our base. And this is also what we're gonna show in our book. So one of the things of, sorry, I just see the chat now. So one of the component of the competition was to have a biomimicry aspect within our base, and we came up with the mycelium. So the myceliums, they're this fungi that they grow, and they create this network, and this network keeps growing. And the beauty is that it can give nutrients to the surrounding environments. So it creates a community, and that's what we wanted to express. So taking from the mycelium, okay, this is what our future moon base would look like. And one thing that the architects came up with is with this concept of light, because it's a home among the stars. And these, they make us look like really we're on the moon, but we're stars within the moon. And I really like this concept. So, and this, it's what it would look like. And also you don't see the pads here. So we're in the Shackleton crater. You don't see the landing site because, of course, it's a little bit further than the base because of the dust that is going to uplift once the rocket lands. And we also took into consideration this, and we're actually still working on it because it's still So our engineering team is still looking into how we can reduce the risk of the moon dust to spread and come into our habitat, which could be really dangerous. And also one thing that you can see from this picture is that at the beginning, we just had our modules with one floor. Here, we are going to expand into 2 floors. So we can also increase the number of people living within one module. And these are the new renders. So this is our social space. Again, many trees and white walls so that we project the lights. And you see the 2 floors. So this is the upper floor. So this is the ground floor and the first floor. So we made sure that people fit into nature, not similar to Earth. We cannot replicate Earth, but something that can feel, that can let them feel connected back to their birthplace. And this is an extra model. This is our farm module that got expanded, and we're here. So where we are right now, we can be self-sufficient in terms of food production. And this one instead is our warehouse. So one thing that we took into consideration is that humans cannot really do it on their own on the moon. So we rely a lot on robots, as you can see here, but also on rovers, for example, even just to go and look at the geological features of the moon, especially at the very beginning where we're going to live there. And yeah, I think that was it. So we presented this project back in April to the SSEA, because one thing that we would like to do is to, for the book, which are going to be in this slide. So our future, what we aim to do in the future is, of course, to publish our book, and then to, depending on the book's success, also to expand the project within SGC and develop some educational material to be integrated with it. So when you're reading for example, the engineering chapter, we will have some hands-on project or more kind of focus text, more explanation on how things, for example, the launchpad has been developed. And of course, we aim to collaborate with other associations, for example, the Students for the Exploration and Development of Space, not just to promote the book, but to promote the space itself and to show people that space is actually fun. And you can, by combining all of these subjects, you learn a lot. Also on how, how you could bring all this knowledge back to Earth. And we also hope to do later some hackathons, competition, of course, conferences. And I think, let me know how we do with time, but these, okay. And one thing maybe that I didn't talk about that much is when we were developing this, also for the Moon Society competition, we took into consideration how we're going to impact the moon, because we're building a base. This means that we're going to change forever how the moon looks like in the specific region. So how are we going to record this? So we all thought to have within our base, especially in the main area, a museum to show how we came this far from, from beyond Earth, looking at the stars, to actually living among the stars now. How do we do this? How we can transmit this to the future generations so that they take care of the surrounding environment and understand how, as one species, we were able to achieve this. So one very important thing that we're trying to develop is the tourism. It's not just like tourism, oh, look, I'm on the moon, I'm on the space, I'm on space, but it's, for example, bringing them outside the moon base and let them do kind of a walking tour-ish, for example, and bringing them to the first human footprints on the moon. So let them understand how we were able to achieve this. And considering this, within the book, we're trying to develop and to promote both human heritage and environmental protection policies to understand, is this feasible? Would this ever happen? Or are we going to make the same mistake over and over again? Yeah.
Wow, that's quite amazing. I would love to have more time to talk with you about some of these things. One quick question. So you had 30 rooms. The guest rooms, I'm guessing, are going to have 1 or 2 people. So maybe this is 40 people. Is that kind of the target?
Yeah, so 40 max for this initial part. Yeah.
And I thought the idea of just having the number 2 module that is just totally dedicated to being social, that's a piece I think people really miss a lot. So yeah, this is fascinating. I'd love to kind of dig in deeper with that. You're out in Portugal right now, yeah, with International Space University, yeah.
Yeah. Right now I'm volunteering kind of as a staff member for this year program.
Nice. Have fun out there. That's my other pin right here. So all right, Celine, thanks so much for being a part of this. Thanks for sharing this. I can certainly see why you've won these awards. Appreciate it. We're gonna sign off now and bring over Terry. Thanks a lot, Celine. Bye-bye.
Thank you. Bye.
Good morning, Mr. Trevino. Are you in Hawaii?
How can you tell?
So we went from Portugal, and 15 seconds later we're in Hawaii. So that's how we roll in the
that's how we roll.
That's how we roll in the Moon Society, right? This is a global conference to talk about.
We have to, right? I've been a member for more than 2 years now. I think this is my 3rd year at the Moon Society. So
yay.
Thank you, Michael, for inviting me in. You actually invited me into the Moon Society a couple of years ago. Thank you.
Yeah. Let me read your quick bio. Trevino has a long and storied real estate career, and over those 30 years, he has remained passionate about space and chasing his desire to become an astrophysicist, which he just finished recently. So congratulations on your defense of your master's. Trevino finished up a Master's of Science in Space Studies with a concentration in aerospace science and an emphasis on space operations. He was recently inducted into the Society of Physics Students of the American Physics Society. He is the assistant manager of the University Observatory and successfully defended his thesis on exoplanets and eclipsing binary star properties using ground-based telescopes, searching for protoplanetary neighborhoods where they live, leading to several studies, including a supernova research group studying an SN1A supernova. He is on the team developing a satellite tracking software using MATLAB, working on and seeking several grants for a peer group of master's and undergrad students, and the propagation of algae in an ISS study. So today he's going to talk about moon bases, and on Saturday he's going to talk about algae. So you're wearing 2 hats today at this program. You are the only speaker that we have doing 2 back-to-back presentations. So Terry, really, for all of your support, thank you very much, sir.
Always, Michael. Yeah, I'm a big fan. You know that.
Yep. Thank you very much, sir. I'm going to turn the screen over to you for a bit.
Awesome. Coming on. Here we are, folks. We are clearly going back to the moon. I believe Tuesday we get an update from NASA as we are approaching our, excuse me, what appears to be a liftoff of Artemis 1. So hopefully that goes well. And the update is what we're looking for.
Yeah, there's an update happening concurrently at NASA right now. Today.
Oh,
yeah. So
perfect.
I'm really curious to see what happens. I'm going to be checking my my news feeds periodically, but yeah, at 11 o'clock. So I guess it happened an hour ago. At 11 o'clock, there was a news feed from NASA I wanted to catch.
I saw the email.
Okay.
So we're heading back. One of the keys to and the topics that I've started working on is how do we test before we invest these dollars? Putting my real estate development hat on, and that's really what an analog and terrestrial environment really help us do. We are. Where am I at here? There we are. One of the things that I've kind of started working through is how we use these missions, to just understand form and function of the interior of these facilities. More importantly, clearly aerospace science hat.
Recording in progress.
Put the aerospace science hat on. There are a lot of things we have to consider. I love the previous presentation because it just makes me think that we're that close. When we start looking at and discussing what these facilities are going to look like on the surface of another planet, if you can call the moon a planet, it just excites the heck out of me. We're clearly going to need radiation hardened habitats up on the lunar surface, maybe even on Mars. It depends on how long we're there, of course, but one of the things I've been working on recently, particularly, how do we do that? Power, we're going to need a ton of power up there. Sorry, no offense to solar cell technology, but it's not there yet. We're only getting, 500 and 600 watts out of a solar panel, and that's just not going to cut it unless we all want to, I think we're going to suffer through if we don't have more power. I did work recently at the University of North Dakota's ILMA science labs. They're a fairly realistic and if you ask me, probably of most of the facilities on the planet right now, probably the best as it relates to testing and research and science. They do have a very realistic spacesuit that we can don and off, and of course I worked on my algae project. Some of our team members, the plant module, one of the projects I'm working on for radiation hardening is in the middle up at the top there, right here. These are a couple, again, the two of us in these blueberry and then in tangerine. The suits are desperately realistic when you put them on. They're actually made by Dr. Pablo de Leon, who's famous lunar suit developer. That is the NDX2A, A for analog. Mission patch, real quick. Mission patch was just, we were hoping to perform this past mission. We were hoping to perform a Mars relay environment and try to delay our communications by 10 minutes, and practically impossible. All of us needed to be kind of in touch with Earth, so we transitioned to the moon. The habitat itself lays horizontally on the surface. So the modules themselves are all working modules. You can kind of see the core module is where we live, we eat, we visit, we meet. We've got a rover tunnel, a rover that actually moves around and on and around the facilities on the campus, by the way. So we kind of traverse in the rover along and around the campus. Greenhouse module I spend most of my time in, very modern, great lighting. We've got some things to work out. Similarly, right, we're on the surface of another planet or on the moon. We're going to have to test. We're going to have to understand, the individual little nuances of these modules as we get up there. EVA station, boom, right there. You can't mess it. Central control airlock, awesome. I lit it from the inside. I did some really cool stuff with lighting because I think that's really important. One of the things I work on, particularly as we get up into and on the surface of the of the moon is how do we integrate in using regolith, Martian, lunar regolith? How do we get that involved? Making blue-green algae, how does it grow? How will it perform if we use that as an additive? If there's any DNA changes, we send those samples off for DNA monitoring. We are also in those suits a lot, so we spend a lot of time walking around the facility, just minding the facility, managing it from the exterior. We had you're going to have sewer problems on the surface of any planet, so had a sewer problem, had to don the suit, had to go out and determine what the issue was. It was aeration, thankfully. Habitat design, layout and flow. I'm not saying that the University of North Dakota have perfected that layout, but it's fairly, it's realistic, right? It's what we expect, right? When we get out on the surface, we can ingress and egress each module individually if we need to. And I think that's going to be very important on another planet, which, by the way, makes the entire process a lot more expensive. You've got to have those modules that will allow for compress and decompress. I think that's really something to consider. We did a lot of studies on isolation, understanding how our human psyche will respond to the delay in communications, the living in very close quarters with other people, and that was a very interesting and dynamic environment. We also did energy and nutrition studies. How much energy are we spending when we're out and when we dawn and when we go out onto the surface of another planet? How much energy are we using? How much nutrition we're going to need? Fluids we're going to need? We did that as well. This is new. You probably not seen this, Michael. So, ta-da, reveal. This is from the Diana Project over in Europe. It is a paper that was presented last week at ICES. It's spectacular. They've really come together with several international students. Alma Kugic actually gave this to me. Kugic, sorry, K-U-G-I-C, Kugic. She actually provided these two slides for me. Her presentation was performed by another one of my UND cohort, and it's more than likely very realistic. Each of those orbs, if you want to call them, are perfect for a 9-meter fairing, and we've got some little things that we'll do, and I can show you in a second. The modes themselves, again, you can see the 3 locks. There's the central core lock, or what they call a primary node. One of the so ICES, Michael, I know you know this. It's pretty impressive. All things NASA, everybody was there. All the old school NASA folks were there, and so I actually couldn't learn enough while I was in that in all those different meetings. There were actually too many to discuss, but you and I should talk offline about some of the things. The module system itself, perfect, where these individual nodes will be able to bring up multiple at the same time. The primary node, probably not, probably a single event, depending on fairing size and who and what lands. I'm really looking forward to see if we can get one more primary node or another module of some kind over on this backside, kind of close that system up so it's a full loop in case one of these fail. Here's there were several slides. I just told, I asked Alma, I said, please just give me 2 of your slides. This is the habitation social module. Brilliant idea. Really just kind of fits into what you were just speaking with the previous speaker. A lot of the things that I thought were really cool are over here on the right. Size in terms of meters squared. I think that should be meter cube, but only because I know that we're in a XYZ environment when we're up there. I found this really fascinating. So the units themselves can expand and lift, and then and not necessarily inflate, but flex out. So it's almost like an erector set that opens and closes. One of the challenges and one of the things that we're thinking through the project itself, how do we get a regolith on the exterior of these? So when you go back to the previous module, she had a beautiful slide that I could show you later offline. It's stunning, right? It shows where it would sit near the Shackleton, how it's going to fit in that environment there. They actually chose the exact spot where we probably will land our first module nodes, and it was spectacular. It was, anyway, I've got the paper as well. I can share offline with anybody later. Analog sites across the world, there are several. You and I know that. Some of the ones that I think are very realistic, High Seas was there. High Seas is now Airbnb. If you guys need a spot when you're in Hawaii, I'm here now. I'm actually not far from High Seas. It's just up the hill here. And Mauna Loa, really an all-imposing mountain. Ilma, I think probably with respect to science and research, spectacular. Amity in Poland, another brilliant space. Nemo and Aquarius, I've just got selected into the underwater Aquarius, and I'm doing that in 2024. I know that's going to be exciting. MBL would be awesome to get some time in there, but I don't think I have the street cred yet. Notice I said yet. Here are all the others that are out there. I think with science in mind, Houghton Crater is a great spot, even though it's maybe a little more Mars analogy. Also brilliant for research. And yeah, there's all the different places if you want to go and try to figure out how we're going to live on the surface of another planet. Boom. We are going back. If you catch a ride, in the famous words of Haddon from Haddon Industries in the movie Contact, we are returning to the mood. Do you want to catch a ride? Anyway, thanks to everyone. It's my website, Space for All. We are for profit, but I'm not making money, and that's not the goal here. It's just to. Awesome. Diana was our slide provider, and I am going to stop sharing.
Thanks a lot, sir. That was awesome. Man. I was going to have you come back to some of those slides if you don't mind.
Yeah. Oh, sure. Go ahead.
The habitat site. Well, let's talk about your experience in the Ilma first.
Yeah.
So how many people go back to the Ilma slide?
We can fit 4 in the core module. The sleeping quarters themselves are about 9 meter cube.
Okay.
Pretty small.
So my immediate question is, if we want to scale up to Celine's version of 30 people, is there a way to make Ilma expandable for 30 people? Because it's a really different experiment to get 4 people up there versus 30 people. That is not, that's not just a simple math multiplication. The logistics of that become real complicated, which I think we have to do down here on the ground first. So how do we get North Dakota to build a hab that's big enough for 30 people?
Well, I can tell you, Dr. De Leon wants to do the same thing. The core module is probably a bit too large, right? We could fit at least 10 people in there comfortably if we line the walls. I can't share the inside of the space with you. Right. It is proprietary, but we could line those walls with those individual bunks, if you want to call them. They were awesome. You could close them over. You have your own space. I found it practically cathartic, right? You could be within yourself and really focus on your science. The geo module itself was, often it was only me testing some of the soils that I was working on. We've got a really nice microscope in there, and all of the soil testing facility, equipment that we need in the facility. Greenhouse module lined with lights along the walls for vertical farming. EVA equally, the suits themselves, you saw a bit of the inside of that where the suits are hanging on the inside of, and we don and doff from the outside in an airlock, right? We're in an airlock, we don, and then we release and we depress, as we like to say, and then boom, we walk out. Exercise module also quite large, but the exercise module was also the medical bay. And we can assume that there will be always someone with an injury or an ailment of some kind. We get up into the multiples of people. In fact, even at 4, we had little nicks and cuts and injuries that we were, fitting through. I've been on the Elma habitat twice, 25 days and all in. And you will have that issue. It's a good point.
I only spent 11 days out of 4 years in the Marine Corps. I only spent 11 days on a ship, but I was in the med center within 4 hours of being on ship. Because and this is the same, right? Everything is sharp corners and everything is pipes and everything.
That's right.
Right. So I almost knocked myself unconscious.
Those head injuries are normal.
Right, going through a door. So the idea of growing this from 4 people, a 10x, 8x multiple, that is complicated. You don't have any idea what the budget is for running this thing. Is that appropriate to share?
I can tell you they received 2 $750,000 grants from NASA at individual times, so a year apart, and they were able to really just X this up quite a bit.
Cool. Okay.
And I, it would take. Honestly, Michael, I think it would take us, millions to really just pop that up and make it more realistic. There's plenty of space there. There's no question that we could do that. Okay. I hope that, with our work out here, people realize that these plants like Celine's project or like Alma's project and the Diana project, what great concepts, but we really have to almost build our digital twin down here. Right. And really just work through those processes. I want to wrap these with a regolith of some kind, or wrap them with my, one of my my electromagnetic waves that protect it from radiation. So one of the things that I'm working through and part of a project that I'm on. So it's something we're gonna have to think about.
Yeah, it's let's move down the slides a little to the pretty pictures of this, right? It's surprisingly easy to build a rendering. It is shockingly complicated to build this in the real world in North Dakota, and even harder to build it on the moon, right? So given you spent some time, I don't know if folks outside of America will understand the reference of habit trails, but you had these little hamsters that had little balls and connecting wheels and tubes. I mean, I had a hamster when I was a kid. That's what that looks like to me when I look at this.
Yeah.
How easy or how hard is it to move from a functional structure grounded to the ground in North Dakota to this on the moon? Give me some times, give me some dollars, give me some complexity, give me some issues.
Yeah. I think we're talking about, hundreds of millions of dollars now. Down on the surface, we've got gravity. We know how to work well with gravity down here. As we move out into that 16th, microgravity, if you want to call it, even on the surface of the moon, you saw yourself how they accidentally, pop around, and the minute you you barely push off, you elevate, several feet, and unexpectedly probably could, moving to the next module, you could bump your head pretty easily. Just by accidentally just stepping too hard. I don't know if you've seen, I don't like the name For All Mankind. Mankind meaning, I think it should have been For All Humankind, but that's another great example. That show doesn't really tell the whole story from transitioning from Earth to lunar surface. The microgravity there is the difference is significant. You would need these modules to be significantly taller, just for the simple sake of head injuries and those types of safety factors.
Yeah.
I think mass is everything. We're at $2,000 a kilogram on approximately $2,000 a kilogram right now.
Coming down, but yes.
But heading down. And we can't, the math is incomprehensible, right? You start adding it all together. We're in the tens of millions per module. Where are we going to land? I loved Mastin's idea before they went out of business last week. Well, we assume they're going out of business, of solidifying the surface as it was landing, as some of their landers were coming down. They were actually ejecting a material onto the surface that would solidify the lunar regolith. And we don't have that anymore. They're gone. Hopefully that technology transfer happens somewhere there. But again, these massive starships, first of all, I'm tired of us. We can't rely on Starship. We have to go with what we have. And it's going to be the Falcon, and maybe the Falcon Heavy. Certainly the Terran looks very useful. And that announcement yesterday, the day before, that they're going to the surface of the Mars, and going before all of us, very exciting. I think if you add that endeavor of commercialism or commercializing the idea, it's not a bad thing, right? It's going to get us there quickly, which is the goal, is to get there as fast as we can. Dr. Zubrin said it a million times. Why waste the time going to the moon? Well, we have to test. This is it. Test before you invest. We have to figure out that we can carry all this mass there safely, not have everybody die in process, right? Backups, tertiary backups. There's so many numbers, honestly. Sorry, it might be a bit windy here, that we can't quantify, that we just don't know. They are the unknowns. What did, was it Cohen? No, it was one of the previous administrations said, the unknowns, right? And here we are right now. I don't know. I can't give you that number. On down here, tens of millions. Up there, 10x.
Okay, I like tens of millions, and I can even think hundreds of millions. I mean, you've got demonstrated companies, Axiom and NanoRacks, and the combined weight of Boeing and Blue Origin to build out the orbital reef, right? There's demonstrated experience there that's building multi-hundred million, $500 million space stations. So it makes me confident that there will be that kind of money available for lunar, but I think it's a ways away. I don't think it's somebody's going to make a news announcement in the next weeks. I think that's going to be awesome. I think that's a much bigger step than building a space station, right? So
agree.
Yeah, I am curious. I mean, I don't want to throw water on these ideas because I think they're brilliant and beautiful, and I think people have to spend a whole lot more time than 25 days in the HAB to really understand what it takes. Right?
Candidly, I'm not keen on that, by the way. I like my little things.
Yeah. So last question before we wrap up. What's next for you? Are you going back into the HAB? And I know you just said you were slide for Nemo, so super happy about that. Congratulations.
Yeah, thank you. Yeah, that's a big one.
Yeah, it really is. And the Neutral Buoyancy Lab in Houston, it's a pretty epic facility. I've been on the outside looking in. I don't have the street cred to get into and do a test there either, but work on it, man. You'll get there. You'll get there.
Yeah, goals. That would be awesome to get in and work on some habitat design that with the knowledge of what I have now. I think right now I'm literally taking this weeks at a time. So I'm looking only a few weeks in advance. I do have some really cool ideas on habitat protection that seem to be gathering attention, as you well know. So I think that's really where we're heading right now.
Cool. Well, I think it would be great to have some sort of alumni network of all the folks that have been through ILMA and collect that into a resource, because
great idea.
Those folks, as they kind of move out into the world, they're going to have their own ideas, but you can't let those people, that institutional knowledge, like that's you can't let that go. So make sure you keep tabs on your alum that have been through there.
Brilliant advice.
Yeah, thanks. Right. All right, sir. Thank you very much, Terry. We are going to bring Philip back onto the program. And we are, and change to attendee. Terry, thanks for turning you back into attendee. Terry will be here with us on Saturday again, and he's going to go into some of the stuff that he alluded to today on growing stuff on the moon. Philip, welcome, sir.
Hi. Thank you for having me again.
Hi. So glad to have you here. I think what you're going to be talking about today is super important. So I'm just going to let you take it away. Can you turn on your camera?
And
thank you, sir.
Try one other thing. I do apologize. I'm trying to figure out how to share my video.
Oh, no worries. No worries.
I do apologize, everybody.
It's share screen on the bottom, the big green one in the middle.
Oh, there it is. Okay, thank you.
While you're doing that, Phil, how long have you been the chairman?
Sorry?
How long have you been the chairman of
I've been the chairman since I think 2015. That was when I originally started as chairman, maybe a little bit around that time. I have taken breaks since then. We have had other chairmen who've served since then, and they are phenomenal. And they are, we're always looking for great leadership in the Moon Society. All right, so what I'd like to share with you is I sent out a survey just to get things started with us yesterday. Now I understand I've taken data analysis before. I know that when you have 9 responses so far, given that it's only that the survey was sent out yesterday, less than 12 hours ago. Or maybe a little bit more than that, but so 9 responses for this time is understandable, but this is just a preliminary assessment of where we are with our members. This survey was sent to all of our members, so I'm going to try to go through here, and let me also maximize the screen here so you can see it more clearly. So what the important thing to note so far is that right now, understand this is still a preliminary survey. We do have other people who are involved with the Moon Society who are not within the United States. But the United States is right now the primary bulk of our members. We are always interested in expanding our members globally. So there are initiatives right now where we have a few people who are in Turkey right now who are interested in starting a chapter with us. We have people who are in I think the United Kingdom and Ireland who are interested possibly Spain and Portugal. So we are looking to expand beyond the United States. So, if you know of other people who are interested in space colonization and settlement and who would like to participate with us, please invite them to join us. We would love to have them. So right now, based on our sampling right now, which is a preliminary sampling at the early stage. So you can see right here that a lot of our members are UTC -5 is what here in the United States we call Central Time. This is people who are living in the middle portion of the country, roughly between Chicago down to Dallas, Texas. And you can see that there are some of them who are further, this UTC -7 is Pacific Time. I suspect this one right here might be an error or a mistake, because UTC +5 would probably put them somewhere, I believe, in maybe Iraq or Afghanistan. I don't think we have anyone who's a member who's that location. And UTC -4 is on East Coast time. So we can see so far that a lot of our members are in the middle portion of the country. There are with a few who are on the East and West Coast. Moving more, our age group, I didn't want to break this down too deeply. We can always do follow-up surveys and invest in questionnaires to dig deeper into the composition of our members. Right now, you can see that we have a small majority who are working adults, and a lot of them who are seniors. So that difference is it might be a slight generational differences between us, but I think we're all agreed, we're all on the same page of sharing the same aspiration of wanting to go to the moon, and settle there. Educational level. Now this one kind of stands out for me because in the general population, there are maybe a quarter of the population have bachelor's degrees, with maybe 1 to 2% having 1 to 2% having PhDs, and maybe 4 to 5% having advanced degrees. So we are overrepresented within the Moon Society for those with advanced degrees, which is something we would kind of expect with a STEM-oriented nonprofit organization. And so I've also followed the education question up with whether or not they are currently employed in a STEM field. So STEM is science, technology, engineering, and mathematics. So if they're involved in that in any capacity, that would be helpful for us. So you can see, yes is these are people who are currently working. No means they're probably young, maybe considering going into, they're still in school, but that would put us at a kind of a majority of people who are currently employed in the STEM field. But this means that we also have a lot of supporters and activists and people who are who they may not feel that they can enter, they can work or ever live in space with the current crop of people who are going there. But I think they would be interested in going there if they could, if the opportunity was made available for them. So these questions right here, how many nonprofit organizations are people currently a member of? I think I probably needed to word this question a little more clearly, but basically what this means is, if you're a member of any nonprofit organization, not just the Moon Society, so if you are involved with your local animal shelter or your religious organization, then that would also be applicable here. But you can see here that a lot of the numbers are people who, there are a lot of people who here are involved in multiple organizations. And if you look down, we also have kind of like a left-leaning distribution towards those who are involved with at least one organization. And that organization is the Moon Society. And that's understandable with our own members. This is a kind of a, this is an oversampled survey, obviously, because we basically sent this to our own members. I would be interested to see, I think as we do this survey in a longer term, we're going to be able to see, how other space organizations fit in there. And we will also be able to do further research and to find out, what is it about these other organizations, that what is it that they are doing that we are not, that's attracting their members. So that's something that we will dig deeper into in the future. So know that we are considering that. But before I go to the next question, you see that a lot of them people who are of the people who've responded to this survey so far, the other organizations they're involved with is the NSS, the Moon, Mars, and planetary. So there are some who are involved with multiple organizations. So we definitely have, that is also a good opportunity for us to collaborate with these other organizations. So I think we're all, everybody I sent the survey to is obviously on board for, supporting permanent human settlement of space. And I thought this part right here was also interesting because this shows, how did people become interested? We all became interested through different channels of influence. Some people, they just simply, they might have, when they were young, they looked up in the sky and they were inspired by the starry sky, and that hooked them in. And others, but we can see here that in most of these cases, the biggest influence on most of us were science fiction. Speaking for myself, all right, so speaking for myself, I saw that we are I was a young child, and NASA came to my school that influenced me, got me initially interested, and then I just happened to grow up at a lucky time where Star Trek: The Next Generation aired right during my growing years, and that shaped me for the rest of my life. So, and I'm trying to think here. So I'm trying to wrap it up because I'm running out of time here, but you can see here that, we do have people who are interested in space, and those who are active in, so people who are both interested and active in a STEM field, and those who are interested but not active in a space science field. So this is something that we will be going through, more deeply as we get more responses to this survey. We're going to be able to provide hopefully a better and clearer picture of who our members are. So, and I'm trying to see here. I do apologize here. I think I skipped a little bit.
It's okay, Phil. You've got another session. We can go through this. We can go through the other pieces.
Yeah, and so there is another section here on activities. I will be going through that when we approach that, when I discuss the activities section. But as you can see here, I think we got a pretty good idea, at least an initial picture of who our members are and the kind of people who would be interested in the Moon Society.
Terrific. Philip, I want to make sure that you post the link to the chat so everyone who's here can go in and respond to it. It's a complex survey, and it should be. This is not easy stuff that we're doing. But they can fill it out while we're having our conversations, and I think that would be super useful to you. And then we will then go and broadcast it to the other channels that we're streaming on. So while I'm talking about the other channels we're streaming on, I want to thank the folks at Axanar. They are a science fiction community really focused around the Star Trek universe, and they've been a big help to kind of broaden our message. So when you show that link about or that graph about how many people came in through science fiction, I'm not surprised by that. I think that's actually kind of fun. When you sent this out late last night, what did you want to get out of it? If there was one takeaway, what's the thing that you absolutely need to know to function better as the chairman of the Moon Society?
In the Moon Society, I inherited a Moon Society that we basically had the wind taken out of our sails early on. We had a big push. There was a lot of members who initially joined, but then we took a lot of that and tried to privatize it, and it went off in a different direction. We're basically trying to rebuild the Moon Society since then. So when I inherited it, when I joined the Moon Society about 7 or 8 years ago, we've been working on trying to get to a point where we can have a strong community interface that allows people to communicate with each other. That's been a lot of the focus on the Moon Society board during that time. We're now at a point where we're ready to start focusing on trying to develop member engagement, trying to build equity for our members to get people to want to come and stay. And then once they're here and they like what they see here, then from there we can start promoting it, and we can really grow this organization. And there's a lot of potential there. But to answer your question, though, I think what we're most interested in right now is to identify activities that people would be interested in and that would get them engaged and to become involved with us as an organization. What we want is we want sticky power. We want people to join us and to stay with us and stay on board and become more active. And that's what's really going to be focusing on the next section I'm going to talk about, activities. I would love to have everybody's response with that, and I'd love to see what kind of activities you're interested in and what can we do to get you involved. Thank you.
Really beautiful. Definitely post that link, and then again I'll get that shared out to the other channels. We'll come back to you in about, I don't know, a little bit of an hour, a little over an hour. We'll go back to the survey, and hopefully there'll be some more answers, and maybe that changes your perspective a little. So
we hope so.
Post that link, and we'll come back to you right away. Thanks a lot. All right. Good morning, Joey. Can you turn on your screen, please?
Good morning. Can you hear me?
We can, thanks.
Okay.
So I'm going to give a brief introduction. Joey is the newest member of our team here at Liftport. We're going to make a bit of an announcement. Joey, give a little bit of your background and then jump into it, all right?
Sure, will do. So as Michael said to you, I'm Joey Varga, the newest member here at Liftport Group. I just graduated with my bachelor's degree from Wabash College, a small liberal arts school around the Indianapolis area in Indiana. My major was political science with a minor in history. And I met Michael last August, pitching an idea to himself and another member. And Michael and I kind of started up a conversation, and we continued that conversation over several months. And he helped me with a research paper I was writing for school. And then I became more interested in Liftport, and it's just kind of gone on from there. And now I'm working for him. So really enjoying it, really liking it. So we're going to get into, you want me to share my screen, correct?
Yes, please.
Okay. Give me 1 second. You see that? Can you see it? Okay. So as you saw on the docket that you received, kind of like the schedule, I was not the scheduled speaker. It was supposed to be Jim Walsh. Unfortunately, due to some circumstances, he is not able to attend today's Lunar Conference. So therefore, I'm going to be briefly discussing Mercury Learning. Please bear with me as this is kind of impromptu and last second, so I just kind of threw this PowerPoint together. So it's not going to be the full details of what he could tell you, but I'm going to do my best. So Mercury Learning
He will be joining us on Saturday.
There you go. He'll be with us Saturday, hopefully. Let's cross our fingers there. But so Mercury Learning here, it's a publishing company, and it's what they focus on is STEM disciplines, and they tailor to different academic institutions, professionals, libraries, higher education, that sort of thing. So what they try and do is they look at very specific topics, which I'll get into on the next slide, but they do that to try to be more innovative rather than and traditional at the same time. And that's unique in a publishing company that usually is just, a very general book of biology or physics, something like that. So what I was talking about here, hold on, excuse me, is you can see some of these specific books that they have. And this is what I think gauged Michael's and I's interest, is that they have very specific topics. One of them that stood out to me on the right-hand side is unmanned aerial vehicles. So we like this a lot, that is specific, because we can focus on things such as specifically lunar development, or mining of lunar resources, or habitation on the moon. And this publishing company, Mercury Learning, allows us to explore these ideas and allows us to engage with an audience with that specific idea. So we really like that. And Jim believes in having less generalization topics. So, larger engagement with his brand, with the Liftport brand, and with the audience. So we really like that message and how it's communicated. Continuing on, so Liftport is looking to partner with Mercury to create different anthologies, journals, and primers for lunar development, as I said, for Mercury Learning. Doing so will help us as a company, Liftport, expand our ideas and help Mercury at the same time. How we're looking to do this is by creating a TAC, a Technical Advisory Council, and this will consist of different individuals with a high knowledge of these specific areas that can eventually help us write these primers on the moon, on Mars, and eventually beyond. So these individuals are going to eventually author their own books through Mercury Learning through Liftport, and published by Mercury Learning. And so I don't know if this is in the way or not, sorry. So why we're doing this is partly because it's going to be great exposure for the lunar community. I can't really think of a textbook or a publishing company that is really dealing with specifically development of the moon. How do you get there? How do you get people on the surface? How do these people survive? How do these people stay there? And you don't have to come back. How is it self-sufficient? So that's, as I've been emphasizing, that's the big thing here, is that we're going to create books and journals and literature for individuals from 10 years old to 70-year-olds to be able to read, engage with, and become passionate about. And that's going to not only spark interest and gain exposure and traction in the field of space and science, but it's also going to allow us to expand our brand. And it allows this idea to become more realistic and more feasible in the minds of people who are, a little skeptical, or perhaps like, well, why should we invest money in this when we're, satisfied here on Earth? So we're going to try and change their mind by giving them something that's, very easy to read in these primers and journals and anthologies. So that's what we're looking to do. And that is the presentation.
Thank you, Joey. Appreciate that.
Sure.
So this is all kind of evolved. And the reason that we're bringing this to the Moon Society is we can't do this on our own, right? Nobody can do this on our own. We talked with Terry and Celine earlier today. We talked with Philip and Dana and Nicholas earlier today. We can't do this stuff on our own. And there's the only way that this grand vision, this grand architecture that we're looking for is going to come together is if we share knowledge. And this is now, I actually had to look it up. I think today is either our 24th or 25th event. Maybe it's our 26th event. We've been doing this for about 2 years now. And Jim Walsh and his team at Mercury they saw what we were doing and they decide, hey, we, Liftport, we don't claim to be experts at lunar development. Yes, we're trying to build a lunar elevator, and we'll talk about that later. But you, the folks that are attending, you, the folks that are members of the Moon Society, the folks that are watching this on the various YouTube channels, y'all are the experts in some cases for going to live on the moon. So that's what they've asked us to do, is help to vet ideas, strengthen ideas for book proposals, and then shepherd those book proposals into Mercury Learning. Let's be perfectly candid. This is not a good way to make a lot of money. We've looked at the numbers. They're adequate, but not terrific. And that's not to throw Mercury under the bus. That's not what I'm trying to do. But I don't want anybody to think that this is how you make your fortune in your retirement. Writing a book is difficult. It is time consuming. It is really hard to get anybody to read your book. I've got 2 books on the shelf over here that I've put together, and they didn't sell very many. So I know how difficult the marketing is firsthand, which is why we went with Mercury. So what we're looking for from the greater Mars Society community is to source ideas and then help shepherd those into book form that Mercury can then publish and then market to their community. I think this is a big opportunity. I think this is important for not just the Moon Society directly, but also for the larger global community that is going to the moon. We all know that there's several, I think I saw a report that says 225 missions are going to the moon in the next 10 years. I find that astounding. I can't believe the general public doesn't know that. But I think the time to start writing these books is now. So we want to start creating an opportunity to start cataloging the information from the original Apollo days. A lot of those folks are well into retirement, and some of them, unfortunately, are in the grave sites. So some of that institutional knowledge has been lost. We want to make sure that we capture the history and then use that for taking us forward into the future. So please get in touch with us in the making. It's an evolving partnership, but we think that this sharing of information with everybody is super important. So thank you, Joey. Appreciate that you came and put that together. Joey's role here at Liftport, again, is brand new, but he'll be herding cats to the various folks with masters and PhDs that are interested in being a part of Liftport's Technical Advisory Council. He is going to be shepherding book proposals over to Mercury and helping to organize our future event series, the Better Futures event series. So Joey, thanks for being here. I'll talk to you soon. And with that, I'm going to switch gears. I'm actually the next speaker. I didn't really introduce myself earlier. I'm the president of Liftport Group. We're the folks that have been working to, first, we worked to develop a space elevator through, I was a part of the team with the NASA Institute for Advanced Concepts. And then later created Liftport to focus on building a lunar elevator, an Earth elevator. Over time, I shifted my focus away from an Earth system to exclusively work on the lunar system. We think that the lunar elevator can be built now, immediately with current technology. So we've done a lot of work on that. But that's not particularly lucrative, to be perfectly candid. So during the pandemic, Liftport pivoted in order to just stay in business. We started creating some conferences as a service. So we've done, like I say, 25 or 26 of these so far. Because when the world stopped traveling, conferences still need to happen. Information distribution still needed to happen. So we started doing that just to keep the lights on at the company. And it turns out that it's a really important thing. And even though the nature of the virus is changing globally, we think that digital conferences are here to stay. So we're going to continue doing these with the Moon Society as a partner. The Mars Society has been a partner on other events. The chief scientist of US Space Force, International Space University, Mars Coin, which is an important cryptocurrency. We're going to host that conference next week on the 30th. And then the Center for Space Commerce and Finance has been allied with us for a while. And finally, the Foundation for the Future was a primary sponsor for more than a year. So we've done a lot of these and we're really liking them, but we're creating an offshoot of our company, a spinoff of Liftport called Better Futures. So that's currently a brand, but it's going to become its own company and its own team. So with that, I'm going to switch gears and go into my own presentation. Just give me a moment here. Okay. Can I get a thumbs up that you can see this? Thank you. So one of the things that made me switch gears away from the Earth elevator to the lunar elevator is kind of the reality check of the changes that were happening in the space field. You know, I've got my office right here. I've got robots and string and all this other stuff. Because we've been at it for nearly 20 years, over 20 years of different kind of experiments and different kind of developments. But one of the things that really made me kind of change gears, if you will, is the realization that the moon is right here. It is easier to build a lunar elevator. It's about 1/10 or 1/20 the cost. It's vastly simpler technology. It's vastly simpler materials. The rocketry is there, the computing, the communications, all of it exists now. So it's a far easier target than trying to build an Earth elevator. And then over time, I realized that there's more to this than just the elevator that we want to build, that there's an entire global ecosystem, we call it the cislunar econosphere, that is aiming to build out low Earth orbit, geosynchronous orbit, mid orbits, all the way out to the Lagrange point, all the way out to the lunar surface. There's a lot of activity happening here. And I think it kind of calls for a grand architecture. So 2 years ago, almost to the day, the White House issued this document. It is still in force. it's been maintained and upheld by the next administration. This document is only 22 pages. It is absolutely worth reading. It defines, and this was issued by the National Space Council, and it outlined what we needed to do, what American national policy was. And I don't want to offend any of our non-American friends and partners going to space. This policy clearly dictates that we will work together with our friends and allied partners. But this is the goal, to build an ambitious and sustainable strategy. First, we're going to focus on commercialization of low Earth orbit. I think everybody on this call probably knows that that's happening. It's significant. Hundreds of billions of dollars in private money and hundreds of billions of dollars in governmental money is moving into this sector. I find that astounding. When I started working in this field 20 years ago, there were only 400 satellites in the sky. Almost all of them, maybe with the exception of maybe 5%, almost all of them were government satellites. Now, fast forward, we have more than 10 times, maybe 15 times, maybe 6,000 satellites in the sky. And it is likely that we're going to be 100 times more with 40,000 satellites in the sky in the near future. And there are proposals that they're working their way through the various bureaucracies of the globe, that there might be 400,000 satellites in the sky in the next 2 decades. Now, I find that really hard to believe. I did not believe that when I first saw those numbers. But that's backed up by the Satellite Industry Association. They anticipate 60 to 80,000 satellites in the next 10 years. That's amazing to me. I'm told that there are some redundancies in that. So I think the number is closer to 40 to 60,000, but they are actual experts in the field, and those are their numbers. So commercialization of LEO, obviously full steam ahead. But the very next plank in their proposal is return to the moon to stay. It's not about flags and footprints anymore, despite today being International Moon Day, despite this is the 53rd anniversary of landing on the moon. It's not about national prestige. There's certainly an element of national prestige. Let's not kid ourselves. But it's not just about that. It's about science. It's about research. It's about commerce. It's about developing communities that ultimately become settlements, that ultimately become villages and towns. And I'm so happy to be, alive and participating and being a part and having a role in all this. And I certainly think that the Moon Society has a giant role to play in all of this. They do want to go on to Mars. They do want to do deep space science. And the final pillar is about education and workforce. We don't have time to talk about those pieces today because I want to stay focused on the content of living on the moon. But this document, this policy paper, is really worth reading, and it's a short read. And I got goosebumps when I read pieces of it, so I really want to recommend it. Retired General, 3-star General Quast is saying that these are some of the most important conversations in our field. So does the chief scientist of the U.S. Space Force. And I know that people kind of anticipate that when I talk about, on the Moon Society's event, that I would naturally be talking about NASA, but we're going to have lots of people talking about NASA. So I wanted to kind of shift some of the thinking to consider that a new branch of the U.S. military is really seriously looking at what does it take to go to space in a significant way. The U.S. Space Force already owns bunches and bunches of satellites in the sky. And they are one of the elements of when we go to space for real, like when all of humanity goes to space. There's a piece of it. And that's because the role of government is both a catalyst and a benefactor in this grand architecture of going first to space and then onto the moon and then onto Mars. They determine policies, they create rules, and current programs feed into future programs. So the successes of the commercial launch program that got SpaceX to go to the space station with cargo 10 years ago led to the commercial launch capabilities of sending people to the space station. And that led to the new commercial landing programs going to the moon. So we see that there's this evolutionary role of government from current programs to potential programs. And I think that is going to continue and it is going to expand. And this is how we're going to look at it. We're going to look at it through the framework of hardware, which, you know, all space assets are hardware. But you know, what does the financing of that look like? How do we tell that story with our outreach? What are the laws and policies that dictate what we do going to the moon? So I just kind of wanted to like put that in for context, because it's not just as simple as build a rocket, land a rocket, footsteps on the moon. It's not that easy. There's a lot of complicated machinery that makes that happen. And it doesn't matter whether you're a US nation or a US company, an ESA group, or an individual nation in ESA, or a company in Europe. It doesn't matter if you're in Asia or Africa or Australia or South America. All of these things apply to you, and the partners that you bring into it are really important. So there's this concept that I refer to as ACDC: academic, civil, defense, and commercial. In the earliest days of going to space, all of it was research. It was academic, and going all the way back to Tsiolkovsky or Herman Oberth or anybody. They were doing it to just try to figure stuff out, and that eventually led to technical programs at schools. But it started out as a gee whiz, what if we could do it kind of phase, and it moved into the academics, and then it turned into a civil program in the United States and more of a defensive program in the Soviet Union. Those two blurred together. So for a very, very, very long time, if you think that space development is about 100-year endeavor, starts out academically, 60 years ago, it becomes a civil and defense program. And then only in the last 10, 15 years did you see the first inklings of a commercial sector. Now the commercial sector, I don't think it's bigger than the defense sector yet, but I think it's inevitably that it will be. And the commercial sector eclipsed the academic and civil sector a long time ago, like 5 or 8 years ago, maybe more than that. So as the commercial sector gains prominence in this field, it's going to change how this grand architecture unfolds. So what are we doing, right? for most of the last 60 years, we've been really focused on one thing, launch. And then once we got better and better at launch, comms and Earth observation really drove everything. And for a long time, that's all you heard about in this whole field. Was launch, comms, and we call it EO, Earth observation. And that's all there was. That's all there needed to be. Now you could toss in GPS, but GPS really only came into its own in the last, well, I'd say the iPhone made GPS ubiquitous. That changed an awful lot of stuff. There's a terrific report from a group called Space Capital, that has, I don't know, a 40-page report on just how valuable GPS is to the world and how GPS evolved into its own industry. It's pretty interesting. It's worth reading. But we spent most of our last 60 years in just this one little circle, launch, comms, and Earth observation. And when I started 20 years ago, that was the only thing anybody was talking about. It was the only thing. There was the mythic idea of in-space transportation, the idea of some sort of space tug that would get you from where you were to where you wanted to go. So the idea is we launched a low Earth orbit. To geo is more expensive, so you'd have a space tug to move you back and forth. Well, now in the real world, there are, I think, 3 or 4 operational space tug companies. Two of them actually are in orbit, and 2 of them are near orbit. So you've got space tugs that are going up, meeting up with clients, and doing what they're supposed to be doing. That's a brand new development. I think it's only 2 years old or 3 years old. Pardon me. Excuse me, sorry. So in-space transportation is the next necessary step for us, for humanity to kind of take advantage of this cislunar icanosphere. We have gotten really, really good at launch. Oh, I was going to mention one thing about launch. SpaceX this week matched the entirety of its launch manifest of last year. Let that sink in. We're only in the end of July. We still have a long chunk of the year ahead of us, and they matched what they did all last year. Their cadence looks to be about every 6 days, to launch something about every 6.4 days. That's astounding. We're going to talk about Starship Singularity here in a moment, but and I don't want to come off as a SpaceX fanboy, because I went on record a long time ago saying I was really skeptical of the SpaceX approach. I've clearly been proven wrong. It's a really interesting approach. I thought it was going to be really harmful, but it's worked out really well. So we'll talk more about that in a minute. But I talked about 6,000, 7,000, maybe 40,000 satellites in the next few years. We've mastered this. So once we've gotten that, then in-space transportation becomes more useful, more viable. Now, I'm not going to spend a lot of time on our lunar space elevator infrastructure, but I will say that the price to construct my lunar elevator has dropped maybe in half because of the value of in-space transport, and that launch is getting better and better. So every day, the Earth elevator gets harder and harder to build, and maybe less and less important. And every day, the lunar elevator becomes more useful and easier to build. So we'll talk more about that on Saturday. But I think these things all lead to space stations, and space stations are, I think, the key to humanity's future. We already have one orbiting asset that's been up there 20 years. We have another orbiting asset that's been up there for, I don't know, 18 months with China. It's still very much under construction. A new piece went up last week. We got people in orbit. There was a week at the end or at the beginning of this year where we had, I think, 21 people on orbit or 17 people on orbit. It was some giant number that had never been that we'd never seen before. And we know that there are companies putting multi-$100 million checks at risk for building space stations, commercial assets in space. All of these things are necessary precursors for getting to the moon. As Terry Dorina just said a few minutes ago, Dr. Zubrin with the Mars Society is, originally, I think he's changed his tune now, but originally was saying bypass the moon, go straight to Mars. I really don't think that's likely. I don't even think it's advisable. I like Dr. Zubrin a lot, but I think he's wrong on this. That the moon is a vital test bed. I want to get to Mars super fast. I'm definitely a lunatic more than I am a Martian. But I think that I don't think people are expendable assets. I don't think that the training that goes into them are, should be wasted by accidental errors landing on Mars when we didn't take the time to learn stuff on the moon. So I think you're going to wind up doing a lot of mining and manufacturing, probably robotically at first, and then you're going to have space stations on the moon. You're going to wind up doing a lot of stuff with the robots, and you're going to do that with robots for a while. Yeah, there's going to be boots on the ground. There's going to be flags and footprints and ticker tape parades for the lucky few that get to go. But the majority of the work is going to be done with robotics for a while, and you will build up. We saw Terry had a base that had 4 people, and then he's showcasing and then Celine is showcasing a potential base with 40 people. There's a giant leap between those two things. So that's going to be mostly robotics, maybe a lot of telerobotic operations from the Earth Moon Lagrange 1 point where our elevator is going to be located. And then once we finally get all of that stuff done, I think one of the tasks that humanity will embark upon is using lunar resources, mined, gathered, extracted, smelted down, whatever refining needs to happen. You will eventually start constructing large solar panels, probably at the Earth Moon Lagrange 1 site, and then shipping them back towards Earth. And you will build giant solar panels over the 300 largest cities of the world and provide clean, green, limitless energy to 40% of the global population. So that's where I think this grand architecture is going to take us. And it cannot happen without a real focused dedication of going back to the moon. Go back for a few days, go back, build an outpost, go back, start mining and building assets. So it's going to take a while. I mean, this isn't easy stuff, but I think that's where we're ultimately heading. All of this stuff comes together only because we've gotten better at launch comms and Earth observation. there are proposals to go to the moon and provide comms, observation, and launch from the moon already, right? You're gonna need some the lunar equivalent, the Selene equivalent of GPS. You're gonna need to know where this this crater is that you found all the ice in. You're going to need to know where this crater is that found all the creep, all the rare earth elements. You're going to need comms. You're going to need a lunar equivalent to GPS. So that's all coming just to make this possible. Right? It's so close, but it's just, we're not quite there yet. We're getting there. We're going to go all over the moon, but I think we're going to wind up in the poles. I'm especially interested in the equator, but that's a self-serving position because that's where our lunar elevator goes. But this is what we're going to wind up building. By pulling resources off of the moon, everybody talks about asteroid mining. That was a big hot topic 5, 8, 10 years ago, monumentally hard. Despite 6 companies trying, 4 of them were well-funded organizations with backed by billionaires. That target was just simply too far away. The ROI didn't make sense. There was a lot of stuff that was maybe a little too soon, a little too early. Whereas had they put those exact same resources into going to the moon had many of the things that they claimed that they wanted. And that would have powered the cislunar econosphere. So I think they had the right idea, but they had the wrong target. But we're going to build out an ecosystem that encompasses all the way all the way around the moon to include all 5 Lagrange points. That's where we're going. It's going to take a while, and to kind of bring U.S. Space Force into the mix. Their official mandate, their doctrinal mandate, is they control everything above 100 kilometers. So let that sink in for a second. The Air Force, Army, Navy, Marine Corps, they all have their zones of experience, right? You don't send, the Navy sticks to the shores, the Marines stick to the edges of the shores typically. Army goes in a lot of places, Air Force goes in a lot of places. They all have very geographically, and I use that word on purpose, geographically confined missions. The mission of Space Force is anything above 100 kilometers. That's the Kármán line. Well, that means all of low Earth orbit and geosynchronous orbit and the moon, but it also means Pluto. It also means Alpha Centauri, right? So I'm not sure that the folks in Washington, D.C. thought that one through very clearly, but given all my interest in science fiction, I think the idea of a Space Force going out into the wild blue yonder, or the wild black yonder, if it were, is pretty exciting. So, but right now, they're focused on this cislunar econosphere. And I think we're going to wind up with some big space stations at the Lagrange point long before we build out large settlements on the moon. I think we're going to do it incrementally, even though I think there's a lot of wealth to be developed off of lunar resources. So it's going to take time, but it's going to be fun. I'm going to switch gears here. I'm going to stop presenting, and I'm going to talk a little bit more about this concept called the Starship Singularity. So about a year and a half ago, we were giving another talk for a different client. It was the Foundation for the Future, and the Moon Society's own Michael Mealing, at the time, I think he was president, if I've got his title correct. Michael Mealing and I were talking about the investment field of space. Michael's day job is he's a manager, a partner of a space investment company called Starbridge. And we were talking about kind of the climate for investment in this field. And one of the things he brought up was that no one is really factoring SpaceX's Starship into their business plans. And I thought that seemed really strange. And then I started digging into it a little bit. So for those that don't know, SpaceX is developing a mammoth new rocket. They've had 23 tests at different levels. Some of them were pretty spectacular, catastrophic failures. They learn every single time, so nobody thinks that's a failure. And they have a pretty fast test cadence. So they're going really quickly to develop this massive, massive capability. And what is massive? It's 100,000 metric tons to orbit. Let's put that in perspective. So far this year, SpaceX, with something like 32 launches, has launched 300,000 metric tons. And with this new rocket, one spacecraft will launch 100,000. And here's the thing why I call it a Starship singularity. And this idea of singularity is based off to Dr. Werner Vinge, who created the concept of technological singularity. That's another paper worth reading. Werner Vinge, Technological Singularity. Where he said that computing is going so fast that it will change everything, and in fact, probably will eclipse the computing power of a human, and that's going to make the world change when that happens. And I think he's very accurate. He wrote that article 30 years ago, and I think he's right on the money with his timelines. So given that historic context, I started looking at Starship and saying, okay, there's a different kind of technological singularity, and it's going to be a rocketry-based singularity where everything past a certain point is unrecognizable. That was Dr. Vinge's claim, that once we get to a certain amount of computing power, that everything past that will be unrecognizable to the person who was on the other side of that line. So there's a line, right? And so we're coming up to a line where this one rocket, once we hit the stated goals of SpaceX and Elon Musk, once we hit that stated goal, that we don't really understand what the world is going to look like on the other side. So the stated goal is 3 launches a day, three flights a day, 1,000 trips a year, at 100 tons per flight. We absolutely do not understand what the world is going to look like on the other side of that. Now, that seems like a crazy claim. And when he first made it, it seemed pretty ridiculous. But he's got that company has a habit of making bold and audacious statements. Maybe they don't hit them on schedule. They're not really good at hitting things on schedule, but they are really good at hitting them anyway. So I don't know how long it's going to be before there are 3 launches a day from Boca Chica, Texas, and from Florida. But that day is coming. And when it does, the world is going to change. And I said a few minutes ago that there's soon to be 40,000 satellites in the sky. If it's a clear night in your neighborhood tonight, go outside and just look up at the stars. When I was a kid, 14, 15, 18, I was in Boy Scouts. I did a lot of camping outside. And I remember seeing a satellite, and it was a big deal. It's like, wow, there's a satellite, right? Like, I thought the stars were cool, but wow, look at that satellite, because you didn't see them all that often. And now you can just look up at the sky at any moment and see these, moving stars across the sky. So if there's only 6,000 up there now, and there's going to be 40 or 60,000 soon, you may want to go look at the sky. And that is a singularity of a kind, but that's not going to happen overnight. That's not going to happen immediately. The singularity that I'm talking about is 3 rockets a day, 100,000 tons. To put that in perspective, it took 15 years, more or less, to build the International Space Station, to construct it one piece at a time, one shuttle flight at a time. It was super complicated, right? You could construct the space station in a weekend, in 2 days of SpaceX's launch capacity. You would be able to construct the entire International Space Station. So then when you take Starship and the Starship singularity into account, you can start seeing these images that Terry was showing, that Celine was showing, about large habitat environments. I don't think those organizations are taking the Starship singularity into account either. So the commercial sector is not really good at it. Certainly the academic sector is really not very good at factoring in this Starship singularity. But it doesn't just stop at SpaceX. SpaceX is the leading company for sure, but then look at all of the other companies that are following the SpaceX example. India, just a few days ago, had its first commercial space launch. There's now, I can think of about 8 countries that currently have the ability to get to orbit, and more are in development all the time. There are 60 or 70 national space agencies, certainly not with the same budget as NASA, but that there are 60 or 70 national space agencies. That is a change, and that has been happening over the last 5 to 8 years. So it's not just about this one company, it's that the changes that are happening because of this new technology will be an ever amplifying ripple in this pond. And we don't know what that's going to look like, right? So if you've got the ability to launch 300,000 tons a day, and we all know that SpaceX has precision landing capabilities. So what does that do to the commercial airline industry? Do you take a 3-hour flight to Florida and then for me, I'm in Washington State, a 4-hour flight to Florida, and then take a 45-minute flight to Australia, right? Instead of 15 hours. Just weird things like that. What if there's a combination hurricane and earthquake, like what happened with Haiti last year? You could send an entire medical team, a hospital, a communications repair team. What happens if the Russians invade the Ukraine? Is there a military response? I'm a former U.S. Marine. The idea of space Marines has been a favorite topic of mine since I was, I don't know, 14 or 15 when I read Starship Troopers. So the world changes in ways that we cannot recognize or appreciate, in the same way that no one saw Twitter or Zoom when they first invented the internet. You know, the idea of a virtual conference, we've already had speakers from Portugal and Hawaii. I think that's a 9-hour time zone difference, maybe a 10-hour time zone difference, back to back. That was completely unfathomable just 5 years ago, 10 years ago. So we're moving into a world where we don't really understand what's going to happen when Starship and all the other companies, all the other countries develop this capability. Certainly, it will have impacts and influence on the on developing the lunar sites, right? We're going probably to the South Pole because it's easier, because it's you know, the water ice content is there. What happens when a Starship tries to land on the moon and blows regolith around the entire super thin atmosphere? I use the word atmosphere very loosely, of the moon. We don't know what that's going to look like. Do we risk blowing away Neil Armstrong's footprints accidentally because of rocket exhaust? And I'm not being sarcastic about that. The only erosion possible up there is going to be stuff that we cause. So the idea of this Starship singularity combined with the idea of this grand architecture really does change what we're doing and how we're doing it as we move out into space. First, to really harness the potential of low Earth orbit and geosynchronous orbit, which, even though we've been there for 50 years, 70 years, Sputnik 59. No, 57. So we've been going to space for a long time now, but I don't think that we've really harnessed its fullest potential. And I think we're just about to get to a brand new tipping point. All the stuff that made the spaceships, all the stuff that made SpaceX's Starship possible, all of the things we talked about before, the hardware, the business, the outreach, the framework, the laws and policies, the financing. I don't think anybody in the space field tells their story well. I think we're all pretty terrible at outreach, but that hardware it's going to change the world in some really unexpected and profound ways. So I really am excited about, you know, what's coming and what's next. So stick around. It's going to be a bumpy ride, but I think it's going to be fun. Okay, and with that, I'm going to switch gears here. Just give me a second. We are moving on. We're going to come back to Philip now. Let's bring you on here. I'm going to stop sharing this stuff. Here is Phil's survey that I'm just posting now. Phil, I did not see that you had that in the Q&A section. I asked to put it into the chat, so I didn't see that until just a moment ago. I'm going to ask folks to take a moment or two and go to this survey and fill it out, because it's important. And I am promoting Phil now. And Phil, I'm going to take that same survey and toss it into the streams. Hey, sir.
Sounds good. Yep. Thank you for having me back again.
Of course. I'm trying to do a little bit of admin stuff in the background here. Yeah, let's dig into that. Let's dig into that survey some more and see what you got.
All right. So yeah, so the survey had really three different parts to it. The first was I wanted to just get information about the member. The second one is I'm getting information. I put out some possible activities we could engage in. And finally, the last section is, I wanted to find out how much people are willing to become engaged or involved in these activities. Also understand that these activities that I'm recommending are by no means a comprehensive list. If you have any other activity you don't see in this list and you'd like to suggest, there is a section in the survey about putting forth an activity that we can engage in. All right, so with that said, so the survey is basically, I split it between, I split the type of responses to three different kind of responses. The first is, I wanted to see if people are just simply not interested or in any activity. The second one was I wanted to see if people have a mild or casual interest, something that they wouldn't really think about actually participating in, but they might consider at least donating or supporting financially, which would be appreciated. The other responses were activities that people could participate in, and finally activities that people would consider are confident enough that they would consider taking a leadership role. All right, so with that said, I listed, if I recall, about 30, maybe 40 different possible activities.
Phil,
The first is
Phil, I'm going to ask you to enlarge your screen.
Oh, yeah, sorry about that.
Yeah, sorry, I missed that note when someone was telling me, and I wanted to make sure that.
Yeah, sure.
Yeah, thanks.
Let me get back to here. All right. Yep. So you can see here that the first one I recommended was a maker space for space technology. So if you have like a simulant, or if you could think of some kind of technology you'd like to work on, a space-based maker space would be something that we might be able to develop as an organization. The way I would envision this is we would have maybe like one site that would be the site of the makerspace, and then we would have people we would have a forum where people could discuss or propose online digital designs or some kind of three-dimensional representation of a certain piece of hardware, and then we can try to design that within the makerspace. If there is some hardware that you might be interested in, we can even try to develop a kind of a group that with a budget where we can send parts to different people, and they can work on a part, and then we can forward that part over to another person. So in that way, collectively, even though you're working online, you may be able to still develop technology as a community, and we can and we can even operate that online as a community. Another suggestion I had was if we could do if people were interested in space-based STEM courses. So, for example, one of the key geological rock types on the moon are basalt and anorthosite. Basalt is a type of material. It's kind of like the rock that's at the ocean seabed. It's very easy. It's made very quickly. It's also the kind of material that's made with with volcanoes. It's a kind of a rock that is generated very quickly and it cools down very quickly. It doesn't have a lot of structure to it. But however, if you look at something more like quartz or a northosite, that type of material is something that takes longer to form. But that's the kind of thing that you would learn a little bit about with these space STEM courses. So as you can see here, there's a lot of interest in people who might be interested in having space STEM courses. And there are also a couple of people who may be interested in even leading such courses. This is something that we didn't know before. There's something that I think that might be a potential interest for everybody. And then right on the back of that, do we have STEM courses that can be used for kids? Speaking for myself, I became interested in space when I was in the 3rd grade, and I'm dating myself here. In 3rd grade, the space shuttle just started when I was 8 years old. And I happened to live in the DC area, and, NASA, maybe for, they just felt it was convenient for them to just send out, their PR team from their local headquarters, and they went to our elementary school, and they got me hooked. I remember I had a little bit of artistic ability, and I drew space shuttles, and I was in the 3rd grade. And so that's the kind of thing that, if you spark the right kind of passion in somebody, you can light a fire that'll burn for them for the rest of their life. And I'm proof positive about that. I would say that kind of program works. And, we need to do more of that as an organization. Another one is a moon science course. This is like a kind of course where you actually learn about the features of the moon. It's kind of like a lunar geology course, but it's specific to the moon. You can learn everything about, how the moon orbits the Earth, how it was built, how it was created, just general lunar science. I think that's something that we as the Moon Society used to offer before. We can certainly offer that again. But we're now in a new era where we have the educational technology out there to make it fun and interesting and engaging for people. And as you can see here, there's a lot of interest in people who would consider leading such a course. So there's a lot of potential here, and I'd love to see that grow, that form. So if you are interested in any of these activities that I'm mentioning here, we really want to hear from you. We need your feedback, and we want to get you engaged on this. So what I'm talking about today is mainly I'm just talking about the overview of what we're doing here. Tomorrow on Saturday, we're going to have another conversation like this, but I want it to be more engaging with people. And I definitely want to see who among you would be interested in these kind of activities. All right. Next here is a star party. Star parties, if you've ever been involved in one of these are parties where a group of people, they bring their telescopes to a campsite, to one where you can see the sky pretty clearly, and you can observe something. You can spend the whole weekend observing stars, or you can just spend a single night and you just get a bunch of friends together and you observe the moon. If you've taken a moon science course, these star parties will be a lot of fun for people. I think it'd be an opportunity to get people engaged in these kind of and more, to learn more about the moon, and to get them active with the Moon Society. All right, let me see here. Host a Moon Day event. It can be something similar to today. There is we find a historical date of note. And in our case, July 20th is the Apollo 11 anniversary. There are also other anniversaries, such as the Apollo 17 landing and when they finally left. So the last time we left the moon, that may also be a notable date. We could celebrate historical figures such as Konstantin Tsiolkovsky, Werner von Braun. A lot of people from all over the world would be interested in these kind of activities. And if we celebrate these kind of activities as a society, I think we may be able to get other people involved in these kind of activities as well. All right, let me see here. I do apologize, but as you guys are updating, as more people are responding to the poll, it's kind of kicking me back out. But I'm going to I'm going to doggedly try to get back over here as much as I can. A lunar geology course. I took a geology course when I was in college, a Geo 101, and it completely changed my view of how I look at rocks. I don't look at rocks like a normal person. To me, it's not just a rock. I look at it as, that rock, it forms somewhere. It's part of a broader pattern that exists. What's the story behind that rock? And geology is a fascinating science once you get into it. A lunar geology course is we would take what we know about geology here on Earth, and then we would focus. It would be a more focused kind of geology course where you focus more on the kind of geology that would be related to what we could learn on the moon. If you're interested in ever developing technology or you're interested in colonization, you're going to want to learn about lunar geology just so that you become more informed and then you can come up kind of create ideas. So maybe you want to develop like a mining company. If you learn lunar geology, you can start really honing in and developing a more fine-tuned plan for what you want to do there. Lunar geology outing, I'm sorry, let me go back here. The lunar geology course, you can see there's a lot of interest in that. There are many of you here who are responding to this who would be interested in lunar geology. If there is someone out there among you who's knowledgeable about geology, we would love to have you. We're looking for leadership to participate, to offer people on this. So, if you are familiar with geology, we certainly want your involvement here. And as you can see, and also right with that, there's also a lunar geology outing. Lunar geology outings would be like, for example, going to high seas in Hawaii or other similar geological sites that can be used as analogs for the lunar for different sites on the moon. So being able to go to those outings is something that we as a society may consider exploring. It would be right along the lines of what the Mars Society is doing with their Mars analog sites. Let me go back here. A teleoperated robotic science expedition. It's kind of right on the tail end of that lunar geology course. If we have a web connected robot or teleoperated robot we can put on a lunar geology site, then we can constantly do ongoing exploration of that site. So it would be kind of like a Mars rover concept where you put it on a lunar geology analog site. That's something that will be of interest to you. I don't have much time left here, but I'm gonna try to go through as much as I can. As you can see, there are other possible courses we could explore. And I can see that, based on the blue bars, there's not as much interest in these more practical courses. Some of them, it looks like, that may not be of interest, but as more people respond to this survey, we get a clearer idea of what kind of programs we can offer. So that's something just to be on the lookout for. And I'm trying to see here. So just looking through some of the responses that are, really spiking up so far. Let me see here. This one is a space communications. I don't know if a lot of you who are, you're savvy with computers, you're familiar with TCP/IP, with how computers communicate with each other by network. With space communications, they have something called delay tolerance network protocols. It's a fascinating field. You can basically, you use a network that doesn't have the instant feedback of TCP/IP, and you can learn about that with the space communications course. So if you ever wanted to create like a time-lagged network space simulation, a space communications course is definitely right up your alley, and that's the kind of thing that we can do as a space communications project. Scuba diving. This is kind of fascinating, and today is a good day to really discuss this. I don't know if you're aware of this, but NASA's very first attempt at zero-G, giving astronauts a zero-G experience actually came from Buzz Aldrin. So I want to give my props out to Andy and his father and his family for that. So scuba diving is a good way to get that direct experience from zero G. And this is something that it also a good way. It's also a good way to learn more about operating within a self-contained environment. So if you're interested in more of a hands-on approach to operating in space, you're definitely going to want to look into scuba diving. So scuba diving courses and projects. Courses is something that you can probably do at your local community school. Projects or an actual trip is something that, if you have the disposable income for that, and we do have a lot of retirees out there who might have that, you might consider doing that. And finally, we have this is the softer side of space. This is more like space communications. So 3D art and music. So if you like to create art and music, we definitely want to build a community who can do that. Same with the other things. So one last thing I will try to do before I sign off here is I proposed an idea with the board of directors to come up with a new kind of computer game using the Unreal Engine. It would be a hyper-realistic simulation experience of the moon, and I wanted to give people an opportunity to build up their own vision of what they have in space. So in that way, we don't have to compete with our different visions. We can try to share with each other what our visions are, and then to build on that, collaborate, and to develop a stronger vision that would serve us all. So with that said, like I said, I appreciate your responses, and like I said, I look forward to talking to all of you again on Saturday. Thank you very much.
Fascinating. I mean, we're seeing that the numbers of folks responding has doubled in just the last few minutes. So that's really good. That's good to see. And I'm sure that over time that is going to be a more and more useful survey. So really want to encourage everyone to fill that survey out, both here on our internal Zoom channel and then also in the larger YouTube universe. I've posted a link in all the places. I only just a moment ago found out that the chat was disabled, so attendees can chat if they need to. Phil, thank you very much. We're going to bring on our next guest, and I want to remind everybody that on Saturday, Philip, the chair of the Moon Society, is going to again dig a little bit deeper into the survey. We'll have more results, and not just sharing the results, but what does that mean? What does that mean to the organization to build the organization? So really looking forward to that. Thanks a lot, Phil.
Well, thank you for having me.
Laura, hello.
Hello, Michael.
How are you?
Doing great.
Good. Sorry, I'm still doing some admin stuff on the. All right. Goodbye, Phil. Thank you very much, sir. I don't have your bio queued. Holy cow.
Yeah, it's okay. You can just talk about me.
Okay, good. Sorry. I'm I'm a little bit more prepared than that usually. Laura is all but dissertation, almost a PhD, with a background. I knew her first almost 8 years ago from her work at, was it CASIS then or something different? Yeah, it was under CASIS. That's the national lab component of the International Space Station, the U.S. National Lab. So she was pretty influential in figuring out what did and what did not go to the International Space Station. Mostly the way I know of her was through the commercial sector, what did and did not go up. Full disclosure, our stuff did not go up. She's since left NASA and has become an independent consultant with her company Astrolytical. She does career counseling and industry advice and support to a lot of folks. And I do have her bio in Discord. I just didn't get to it in time. Please add to anything else there, Laura.
No, that was beautiful, Michael. Thank you. And my PhD almost was in lunar regolith. So today is my happy day. Happy International Moon Day. When I was 9 years old is when I decided I wanted to go to the moon, because I learned about Apollo through books, because I'm a little young here to have actually seen it. So that's how long I've had the dream of going to the moon. So we're going to make this happen. Today's the day where NASA actually gave a date for Artemis 1. We're going to see. We have hurricane season in Florida. So we're just going to see how this goes. And of course, technical details and weather aside from hurricanes, we're going to see if it goes to September.
So Laura, we were on this call, so we don't actually know that information. So give us a little bit more on that.
This was announced at 11 o'clock Eastern today. NASA had a press conference saying that we have August 29th as our first Artemis 1 date to launch SLS and Orion uncrewed to lunar orbit. And so this is awesome, because we've been saying for how many years that it's coming up. And then it was supposed to be early this year, that it got pushed and pushed and pushed. So now we're looking at August, September timeframe. Really exciting. For those of you who don't know Artemis, so we're going to do first mission uncrewed, second mission is going to be crewed. It's going to go around the moon. And then third mission is going to land on the surface of the moon. Currently scheduled for 2025, probably going to be 2026 or later. Still crossing fingers. It's so exciting that it's actually happening, because as much as I love Apollo, and I have met several of the Apollo astronauts, they do not represent the entirety of the human race. And so we're looking at sending the first woman to the surface of the moon, the first person of color to the surface of the moon. Artemis 2, which is not landing, but it's a circumlunar, is going to have a Canadian. So we are looking to send not just a better representation of humanity, but like, kick this off. Let's go. Let's make this happen. I am super critical of SLS. I'll admit this, but I still am really excited to see this giant rocket take off. I don't know if I'm going to get down to Florida for Artemis 1, but I'm definitely hoping to, I'll say it here first, because I'm going to manifest this into the universe. I'm hoping to move back to Florida by the time Artemis 3 launches. So I've been down to Florida, moved down there twice, and then moved away. So now third time's a charm. Hopefully I can get back. So all completely off the topic of my talk here, but just so excited to see this information happening, getting this out there today that Artemis 1 has a date. As close to a date as we're going to get during hurricane season in Florida. So really great bio that you gave off the top of your head. So astrolytical, I'm trying to do a better job of explaining what that is. My day job is not actually science communication. It is science analysis or space analysis. It is making sure that especially startups, but really anybody who has space projects can make them happen. And so I work with startups, small businesses, established companies, corporations, government agencies, including NASA, but also foreign government agencies. And as you pointed out, individuals who want to get space careers. So really excited to work with a lot of various people on a lot of different projects. And Terry is in the chat, Terry Trevino, and him. So exciting. I love seeing where my clients go and what they're able to accomplish. So Moon is my specialty again, because I not only fell in love with it when I was 9 years old, I actually went and tried to do a PhD on it. So this is something that I've been waiting for a long time, just getting not just to humans, but also robotics out there to do more science. So that's what we're starting with. Commercial Lunar Payload Services, CLPS. So this is a program that NASA has decided to use their phrase, take shots on the goal and hope to get 50%. So they are contracting with a number of companies to do these small scale lunar landers for small lunars, like robotic, science instruments, different payloads that they will send to companies that may or may not have any experience actually doing this, that hopefully a few of them will succeed. There are 14 CLPS providers that are eligible to bid on these contracts. There are, I think 11. I should have recounted before the talk, that actually have Artemis contracts, including, for example, SpaceX, which is not necessarily a CLPS contract. It is for the human landing services. That's actually a human lander to the surface of the moon. Also really looking forward to Starship. I don't know if I'll get to Texas to ever see it, but I'm definitely hoping to get down to Florida to see that thing go up to orbit and to the moon. So why am I talking about CLPS? Because a lot of the recent news has been about CLPS. So for example, in a talk today at the Glenn Symposium, there was a panel on CLIPS providers, and Astrobotic is looking like the one who's going to go launch first. It was sort of a toss up between Astrobotic and Intuitive Machines. It still might be that Intuitive Machines beats them, but Astrobotic is currently aiming for the end of the year, which typically in space industry speak, that does mean next year. Whereas Intuitive Machines now says that they're going to launch probably January-ish of 2023. Firefly Aerospace is another CLIPS provider that's looking to launch by 2024. And I just want to have a moment of silence for Maston Space Systems. So Maston Space Systems is not dead yet, but they are on life support. I am really sad because this is one of my favorites. So they were also are also a CLIPS provider. They were hoping to get their I think 8 payloads launched to the moon. Not looking good though. They had slipped last year. They announced a schedule slip, and now they're furloughing everybody essentially. Not looking good. So my heart goes out to everybody at Maston, but that isn't to say that these other 3 CLIPS providers that I just mentioned won't go and succeed where others haven't. So Astrobotic could fly as early this year, as I mentioned. That's really exciting. They've been posting a lot about what they're going to be doing, so check out some of their stuff. One thing I want to talk about is the first official Artemis launch already happened, July 4th. Independence Day, although it launched from New Zealand. Rocket Lab launched the Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment Capstone, which is a 12U CubeSat. So it's, not tiny, but it's a pretty small little payload. It's going to near rectilinear halo orbit, the same orbit that Gateway is going to go. So Gateway is the space station, the small mini space station that NASA and other partners are contracting to build around the moon. So that's it's kind of a crazy orbit. If you haven't seen a picture of it, go look it up. It's really interesting. So near rectilinear halo orbit is where it's going to go, because we've never done that before. So Capstone is a technology demonstrator to test not only that orbit, but also some other technology involved. It's going to get to the moon in about 4 months. I think November 13th is when the target is to actually get into lunar orbit. So that's pretty cool that we already have Artemis officially actually started. Unfortunately, we had a little delay recently. Viper was recently announced to be delayed. That's the Volatiles Investigating Polar Exploration Rover, Viper. I've been really excited about this project since a previous iteration of this project was canceled a few years back. And I actually sort of tangentially worked on that project when I did a short stint at Kennedy Space Center one year. And that I think got morphed into Viper. So the idea was that Viper was going to be less expensive. I don't know if that actually happened, but so Viper is supposed to launch November 2024. Now it got pushed back by a year because of the additional ground testing that Astrobotic wants to do for their Griffin lunar lander. And what this rover is going to do is it's going to go land in the South Pole of the moon and look for water ice. We know that ice is on the, it's concentrated in different regions of the moon. So Viper is going to go actually do some ground searching to see how much ice is there and what that looks like. Because we can gather a lot of information from orbit, but we just don't have enough ground truth. But not all the news is bad news. We actually had a mission get pushed up, or get pushed closer. I know you're confused too, Michael, right? That doesn't happen very often. But Lunar Trailblazer, it was a secondary payload on a mission that got delayed, and it's scheduled to get completed by the end of 2023 or something like that. So NASA actually moved it from the previous mission that it was on to a mission by Intuitive Machines, which is supposed to launch earlier. No actual date yet, but I am looking to see what it's also a lunar lander. So Lunar Trailblazer, it's a lunar lander mission, looking to see when that actually launches and when it can get there. The United States is what I've been centering on, but they're not the only ones. We are not the only ones who want to go to the moon. We do have another Luna mission. Do you remember those from like the 60s? So Roscosmos is trying to launch Luna 25, which currently has a date of September 2022. Recently announced that there have been some technical issues with it on the ground with ground testing. Roscosmos says that that's not going to delay the launch date. Like, as someone who is a lunar scientist, I want this thing to launch. So let's hope that they can get Luna 25 off the ground. And it's also going to go to the lunar South Pole. And the executive director for Promising Programs and Science at Roscosmos, I don't know exactly how that translation is, but that's what I think it is, Alexander Bolensko. Forgive me if that's wrong. So he also spoke about Russia's plans to send people to the moon. So if you don't know, there's a vaguely sketched out plan for Russia and China to work together to send humans to the moon as sort of a competitive balancing of the Artemis program that NASA is leading. China, I do think, will be able to accomplish this. Russia has had long issues with budgeting and technical sloppiness. And unfortunately, their space program has been on the decline for quite some time. And now with the war and the sanctions is probably not going to happen. And this Alexander Belensko, he actually pretty much admitted that the crude part of lunar exploration is on hold, or at least quite a bit delayed because of the sanctions situation in Russia. China, on the other hand, has its own plan. So the Chang'e 7 mission, which, if you're not familiar, Chang'e has several missions that have already landed, uncrewed missions on the surface of the moon. There was some really cool science done, like growing a cotton plant, not in the lunar regolith, but like just sending it there, and it sprouted up and then it died a few days later. But still really kind of cool little missions like that. So Chang'e 7 is supposed to go to the permanently shadowed region of the South Pole to launch in 2024, 2025. Now, one thing to mention is why are we having these missions to the moon? Why now? What's the motivator? I just recently rewatched a House hearing, the U.S. House of Congress, House of Representatives meeting from June about NASA's budget, because I'm a geek. So I rewatched it and I noted that over and over and over again, the only witness was a NASA administrator, Bill Nelson, and the only motivator he actually gave was to beat the Chinese to the moon. Didn't even mention Russia, which is surprising during these times, but China. And this is not just a Bill Nelson comment. This has been seen throughout like the Trump administration. It is just a very common theme that we are going to go to the moon. The United States is going to go to the moon to counter China. So where we had the Soviet geopolitics during the Apollo program. This is a whole conference talk could be dedicated to this. A whole conference could be dedicated to geopolitics of where we're going. But one thing to note is that I personally do not think that there is a reason for a competition like we saw during Apollo. I don't think that it is nearly the same kind of thing, but that is the motivator that the United States is using. And one thing that I do think is positive coming out of the geopolitics is the Artemis Accords. For those of you who haven't been following the Artemis Accords, that is a series of bilateral agreements that have been signed over the past 2 or 3 years. Now, I think 2 years, with the United States, so that actually the State Department of the United States and various other countries. And so it goes country by country. So for example, ESA wouldn't sign it, but specific European countries could sign it. And so we now have the 21st signatory that was announced last week. That was Saudi Arabia, which is a little bit of a challenging partnership right there, but it went with like the presidential visit of the Biden administration to Saudi Arabia. So that's why we had that agreement. 21st signatories. So 20 other countries aside from the United States have now signed on to the Artemis Accords, which has a number of different points that mostly reiterate the 1967 Outer Space Treaty, but with some slight additions. For example, property rights on the moon, saying that we are allowed to mine the surface of the moon and sell it. Also, lunar preservation. So for those of you unfamiliar with an organization called For All Moonkind, I highly recommend looking them up. So they are an organization to protect lunar heritage sites. So not just the Apollo 11 footsteps that happened 53 years ago today, but also, any other lunar heritage, such as the lunar missions that the Soviets landed, for example. So making sure that we protect these sites, and also understanding things like zones of, we don't want to call them keep out zones, but like zones of interference. So one thing to keep in mind with lunar regolith is that it goes everywhere, and there's no atmosphere to disperse it in a certain predictable way. And there's also very low gravity compared to the Earth. So some of the regolith that's going to be kicked up is going to go in orbit. So we're going to interfere with each other. We're going to essentially cause harm to the moon. We're going to cause harm to other things around the surface of the moon, and even maybe some things in orbit like Gateway. So we want to understand how we work together with allies and with adversaries. And allies, it's not just countries, we're also talking companies. And I have no time in this talk to talk about just how many companies are involved, because we have things like any kind of infrastructure. Internet, GPS equivalent, the data centers, cloud computing essentially in space on the lunar surface, anything having to do with roads or landing pads, rovers. There's companies right now looking at I'm not talking about the smaller rovers, I'm talking about like human rovers, human driven rovers. I mean, there's companies coming everywhere that want to do business on the moon, that either want government contracts or want to establish their own private business to business company, some kind of business plan right there. Also looking ahead, we can expect there to be lunar tourism. We already have the Dear Moon project, which was contracted in 2019 to send a SpaceX Starship circumlunar to the moon. So that is just the beginning. It's not going to actually launch in 2023, but it will launch, right? I'm really excited to see this because that'll be the beginnings of space tourism outside of orbit. Really looking forward to seeing where that happens to go and how much success they have in replicating that, and how we're going to establish future private missions to the moon, because it's going to happen. It's not going to happen in the next decade, but it is going to happen. I could really talk about this for hours, so I'm going to stop and open it up for questions. I see some things in the chat, but I haven't read them yet. So I'm looking forward to any questions that you have.
Thanks, Laura. As always, this kind of rapid fire shotgun approach to the news, I love it. It's fantastic. And it's so exciting to see what's happening. I'm a nerd, you're a nerd. I think it's safe to say most people on this call are a nerd. The folks that aren't really deep into this stuff absolutely have no idea that it's happening, right? You and I know that Capstone launched. You and I know that there's a date coming for the first trip back to the moon, but your average person doesn't know that. And so these kind of conversations that we're having, I think, are really important. So thanks for sharing your knowledge and your wisdom.
I could say it's less important that you and I talk to each other, and more important that we get the information out there. I actually just attended a couple of weeks ago a special lunar exhibit where they talked about Apollo. And they gave this like futuristic vision of a moon base, but they didn't mention Artemis one bit. And it's because the public does not know. They don't know. Nobody out there aside from our space circles knows that Artemis exists. And so once Artemis starts happening, September-ish timeframe, I think people will begin to pay attention, but have those conversations with your family, with your friends that aren't space friends, with your elected officials. I mean, tell them, call them right now, write them an email, write them a letter, tell them how much this is important and they should fund it.
Yeah, absolutely. It's been fun, as we're watching this stuff unfold. The news about this stuff is starting to kind of percolate, but it's really confined to the hyper nerd zone, and we need to kind of move it beyond. So that's always super fun. You made some comments about you're not really a fan of SLS. Full disclosure, I'm not either, but it's happening, and that's kind of the de facto mission of record here. So let's talk about SLS for a second, because that's how we make this happen for now. So why? So talk about that a bit.
I love rockets. I'm not an aerospace engineer, I'm a physicist, but I still love rockets. So it's not that I'm not a fan of SLS. I'm not a fan with how the program has been implemented. I'm not a fan of the system, where the system says that we must have X amount of dollars spent in key space hubs and X amount of dollars spent in all 50 states in order to be politically viable, in order to have a program at all, and that the US government needs to own and operate its own hardware. Which is how we did it for decades, right? That's how Apollo happened. We had companies involved. The lunar lander was built by Grumman, which is now Northrop Grumman. So it's not like companies weren't involved, but it was NASA hardware. It was NASA owned and operated. And that along with the incentive of spending the maximum amount of money in key congressional districts, means that it was never going to be cost effective. It was never going to be on time. It was never going to be on budget, and it will never be, because that's just not how it's built. Its purpose, it is key feature, is to create those space jobs in Houston, in Florida, in the Mississippi area, in Alabama, in Huntsville. I mean, like, that's its purpose.
I'll point out that Seattle, Washington State, has a thriving commercial space sector, and the nearest NASA center is 800 miles away at NASA Ames in California. So you don't need those official space centers to build a thriving space economy in your local state. So
you say that, but I mean, Boeing and Blue Origin both have major government contracts.
Right. Yeah. But not a NASA center, right? That's what I'm saying. Like, those things happened without a NASA providing kind of gravity and glue. So
to clarify, I'm a big fan of rockets and anything that can get us to beyond. I think it's awesome. And I'm really applauding the people who get to see their work after decades to finally succeed. But it no longer makes sense to have a super expensive project like this when it's not sustainable. And sustainable is another thing that is not yet to be defined. Former NASA Administrator Jim Bridenstine gave a talk within the past week, a few days ago, of what sustainable means to him when it comes to Artemis. And for him, it means being able to get to the moon at any time we wish. It does not necessarily mean being at the moon all the time. And so me as a lunar scientist, I'm like, oh, I actually thought it meant to be there at we had these 2-week sorties initially, but I actually thought it meant sustainable as then we're going and staying, but that's not what it means politically. And it's not what it means budget-wise either, because we do not have the budget, given that programs like SLS and to some extent Orion and other things like the Gateway and that launch tower that got called out in a congressional hearing by Bakhtel. I mean, like, there's just so many things that suck up the funding, so that funding wise, politically, it's very hard to make it sustainable. If you talk to the general public or any congressional person outside of key districts, why they should be spending this crazy amount of money on this program.
That's a really interesting distinction, right? Because I was thinking it was, I mean, here we are, we're at the Moon Society's Lunar Development Conference. The theme is living on the moon. I had interpreted sustainable as permanent, like in an Antarctic style station. That's a pretty important distinction. I'd not heard that.
Yeah, I don't know how Bill Nelson defines it, but that is apparently how Jim Bridenstine defined it. And the next administrator, how are they going to define it, right? The next administration, presidential administration. So these are the things that we need to agree upon as a space community, get on the same page so that we're not sending conflicting messages about what it even means to be sustainable. And there's other ways of interpreting sustainable, economic sustainability, resource sustainability. I mean, there's just different ways to look at how, so that's a really big really big takeaway is how are we actually defining these things and what do we mean? We're not all going to agree, but when it comes to some of these big programs where we need to agree to some extent, we need to have consensus. We need to figure out what that means.
Well, remind me, where is former Administrator Bridenstine now? He's in the commercial sector place.
Yeah, he's back in Oklahoma and he's on a few advisory boards. And
what I thought.
I think he's in an investment company.
In an investment company, right? So maybe not, doesn't have the same role or influence they used to have, but still significant, right? That's a definition that is pretty interesting. I was not expecting that.
I think Andy wants to make a comment.
Yeah. Let's go ahead and bring Andy on here, sir.
Which is another thing to talk about, actually. If you're talking about things like sustainability, it could also mean transportation sustainability, as in the Aldrin cyclers, sorry, misspoke. So I'm sure Andy could talk all about that if he really wanted to. Hey, Andy.
Hey, we can't hear you yet, sir.
Okay, now you can.
Great, thanks.
Okay. Yeah, cyclers, but that would be Mars because cyclers don't work that well for the moon. Sustainability, because this is a really, really interesting and important question. And so I guess what I'm going to say is more of a comment than a question. But so Laura, you hit on the right idea. There are different kinds of sustainability at in the most basic sense, the way I think about it is there's biological self-sustainability, which is really, really important for Mars, right? You have to reduce the amount of stuff that you got to take to Mars to as low a mass as you possibly can, because right now it costs $1 billion to send a ton to Mars. The other kind of sustainability that I think is more important for the moon is economic sustainability. And that is when we have programs, lunar programs, whatever they are. I don't care if they're playing golf on the moon, but that are economically self-sustaining, that the government does not need to spend money on. And the reason we want to be there is so that we can take the government money. And I know I'm going to get flamed for this. I'll get flamed for about 10 things I'm going to say, so I might as well get started. The reason we need to make it economically self-sustaining is so that NASA and other government agencies can spend their money going to Mars, because I think that's kind of what we need to do. There's one other thing that I have probably another heretical thought on, but that is, the money we spend, and we gnash our teeth over it and we worry about it. But the fact is, there is broad consensus acceptance, shall I say, of the NASA budget, and that we spend $10 billion a year on human spaceflight. And that's a lot of money, and it's a great thing. And I think sometimes we worry about that too much, and we ought to accept it. And our task is really to figure out how to spend that money the best way possible. And so that's a little bit of, that's kind of my thought on sustainability.
Fantastic.
Yeah,
Fantastic.
economic sustainability, absolutely spot on. I mean, whether it's golf or whether it's mining or whether it's tourism or whatever it happens to be, I'd love to go play golf on the moon. Let's do it. One thing that you talk about acceptance, and I think that back to that SLS comment, I mean, a few years ago when I was doing congressional visits in person, and I talked to my my congressman and talked to him about the staff wanted to know, do we support SLS? And I'm like, at this point, for political sustainability, we sort of need to. And until maybe things change, when Starship becomes operational, when Senator Shelby is out of office because he's not running for re-election, when Bill Nelson is not running NASA, when things change a little bit more, we can talk then about political sustainability for Artemis. But for now, we accept it.
Yeah. I'm going to leave the Artemis fish on the table for now.
All right, y'all, thank you very much. Laura, we're going to sign off from you. Thanks always for your insights. For those that don't know, Laura is part of just about every program that I host, because she's just so darn good at giving us a roundup of all the news that's happening. So thanks a lot.
Yeah, that was everything. Hey, Laura, if you want to hang on for just a second, I do want to talk about China for a second, because I think
let's talk China.
There's some interesting things about China that are different. I mean, philosophically, I want China working with us on the moon and all that sort of stuff. But the challenge is going to be, there's a bunch of intertanglements that are really kind of weird. And I'll start with something that you mentioned, sort of the exclusion zones. I call them the Metzger zones for lack of a better reason. But when you land on the moon, you send out a bunch of ejecta and it travels a long distance. What that means is that anybody that is within a fairly long distance, call it kilometers, probably tens of kilometers, is going to be at risk. So what that means, whether you buy into the Outer Space Treaty, we didn't sign the Moon Treaty, any of that stuff, what it de facto means is if you're parked somewhere, there is going to be a great deal of angst associated with anyone coming down close to you. And so we will establish norms of behavior that are going to establish pretty big exclusion zones. Okay, why does that matter? Well, the reason it matters to me, I think, and Laura, tell me if I've got this totally twisted, but the moon is kind of like California. You've got Pacific Palisades and Santa Cruz and some really, really expensive real estate. And then you've got the Mojave Desert, which is worthless, right? And so those bits of Pacific Palisades, throw in Santa Monica, are really, really dear. And so whoever gets there first, whether it's government or commercial, I'd rather see them commercial, is going to have a claim on that land simply by virtue of their personal safety. And so I think that can be a positive development, but it does drive us toward competition. And I think it also tells me that the competition with China for the dear parts of the moon is probably a lot more real than the stupid competition, with all due respect to my father, that we had with the Russians. And so there's a different dynamic to it that I haven't really figured out, but it's there and it's important. And we ought to talk about it.
Yeah, those permanently shadowed regions, the areas where we might think that there's water ice in abundance, really looking forward to seeing how we do that, right? How do we divvy that up? And is it an international collaboration, or is it first come, first serve?
We will divvy it up the same way we divvy everything up there. First man's first. And it's not only the permanently shadowed regions, but you sit yourself up on top of that crater edge and you've got permanent sun.
Eternal peaks of light.
No, I mean, there are just incredible little slivers of land on the moon that are going to be just really valuable once we figure it all out. And I think that's a good thing.
Yeah, another thing to keep in mind is like this idea of not just countries competing, but companies competing, because we do have all those CLIPS providers. We do have an international, NASA has contracts out with companies. 2 of them are not US companies, to go and mine regolith, just to have that legal precedence that says, yeah, we can mine the regolith and then sell it to NASA. I mean, location is key. You're absolutely right. Even though the moon is quite big, it's not that big. And you're absolutely right that there's going to be interference.
Really, well, I'm not smart enough. I need somebody smart like you to figure out just how much area there is and how many plots of real estate would you really have on the moon?
I think
price out lunar real estate.
Area of a little bit bigger than Africa, I think, is what it is.
Oh, I think it's a lot smaller than that. But I don't know. Hang on just a second. I have to get my audio-visual gear in order. Okay.
Really excellent points. First come, first serve might be something that really inhibits further cooperation internationally, though. There are some countries that signed on to the Moon Treaty, which the United States did not sign on to, that says that, and essentially that there's no one who should have the rights to own property on the moon or to set up exclusionary zones, which is apparently the same kind of thing, like different language, same result. In a sense.
And I just say good luck with that one.
I know, right? But there are some countries now that signed both the Moon Treaty and the Artemis Accords. So there's something there to be worked out geopolitically.
I think the Artemis Accords are going to be super important. It was a strategic and political stroke of genius to say, here's a document, who wants to sign, and then just watch country after country after country. I thought that was
the political scientists in me said it's just setting up a balance of power between Russia and China. We're setting up a bilateral situation where we're going to have our team, and then there'll be the Belt and Road team.
I'm a little skeptical of the Chinese and the Russians building a document that matches or even compares to the Artemis Accords, right? I understand why China politically cannot sign them. I understand that, but I don't think they don't want them to exist, right? There's a difference, right?
They don't want the documents to exist?
Yeah, because I think they want well, we're going in a completely different direction than we had planned. But
I'm going to bring it back to commercial in just a second.
Okay, good. I think it is very valuable to China that the Artemis Accords exist, whether they ever signed them or not, because
they won't, because it's a bipolar.
Right, they can't sign it, but it's still good for them that they exist. So they won't.
Probably, yeah, because
they won't fight it.
It establishes the bipolarity is a wonderful thing. The Cold War, I grew up in it. I'll get flamed for this one too, but it was stable, and we knew what was going on. We're trying to figure out what's going on now. But I digress. We want to talk about commercial stuff, right?
All right, we're gonna gratefully thank Laura. Thanks for joining us here. We're gonna sign you off. We appreciate your extra time. And I'll see you in a month at our finance event. So thanks a lot, Laura. Appreciate it.
Always great to see you, Laura. Okay, now.
And I'm going to bring in Dr. Andy Aldrin. I'm going to just throw you right under the bus, sir. This is the worst bio that I have received. It says, Dr. Andrew Aldrin is currently the program coordinator of the Masters of Space Operations program at Embry-Riddle University. He is also the president of the Aldrin Family Foundation. Sir, that's a very weak bio, so I want you to fill in the gaps of the things that are not here.
Okay. So, yeah, this is one of those careers that you shouldn't try at home. I began my professional life as a Sovietologist, and I studied at UCLA, and I was at the RAND Corporation with a bunch of other Sovietologists. And I wrote my dissertation on how the Soviet Union beat the United States to the moon. Not to the moon, into space, sorry. And it was a story of entrepreneurship, which was kind of incredible. You don't see entrepreneurship in places like that. But that sort of jolt to the conventional wisdom kind of drove my academic career, and you'll probably see some of that today. But then the Soviet Union went away, which I thought was really bad form, and it wasn't great for my career as a Sovietologist. So I went into aerospace because I had been showing some companies around Russia, which is now Russia, and so I got a job, and I ended up, I was at TRW running business development for a small outfit there that did international business, and then got brought into Boeing, where I ended up as director of business development, advanced programs and strategy for their NASA business, with sort of oversight for all the commercial and civil stuff, and then got moved over to the launch business doing the same thing, and then got moved over to ULA, which was another interesting experiment and experience really too. So anyway, after that, after getting bored with that, I went and ran Moon Express for a year, which was another real experience, and then tried to retire. And my dad asked me to come and help him set up an institute at Florida Tech, which became the Aldrin Space Institute, and which was where we started the ISU Center for Space Entrepreneurship, which we ran for 3 years. And I also kind of took over the Aldrin Family Foundation because we're doing some really cool stuff, but that's just a completely separate direction. Anyway, so I left FIT last year, started a program at Embry-Riddle University, Master of Space Operations. It's at Worldwide. It's an online program. We're going to do another hybrid program like the Center for Space Entrepreneurship next summer. And I've been in touch with Pascal. Hopefully we can find a way to work together with ISU on that. But super excited about the program. It has been the fastest growing program that Embry-Riddle has had. We've got 150 students in it already. And I'll tell you that I didn't know what to really make of online. And one thing I'll tell you is it's a lot of work for the professor that's building the course, because you're essentially writing a book for every course. And then, and the students though they're the best students I've ever had. I kept saying at Florida Tech, because we were getting really, really good students, that the great students I've got, the good students I've got they're unbelievably diligent. A fair number are sort of looking for transitions from one job, if it's in operations in space, into management or something like that. People come, I've got a former sub-commander. Wow. Which is it's astonishingly cool. Anyway, so I'm having great fun with that. And I have something to talk about today. And I'm embarrassed because we had talked about I kind of came into this a little bit late, and I said, yeah, I've got a perfect idea to talk about. And I went back this morning and was putting together the charts, and I realized the charts that I was going to use were the charts I used last year. So if you've seen this, you may have seen some of it before, but I've changed a lot of things around. And so I'm going to do something I've never done before with my studio here. I think it'll work.
Okay.
But so let's see.
Everything in space is an experiment, so we'll learn.
This is an experiment. Okay. First thing I want to do is I can go to here. Where do I get to? Oh, here it is. Choose video. Now something magical should happen where, do you see webcam utility now?
We do, yes, sir.
Now do you see a chart?
Oh, that's nice. Oh, that's on your television?
It is.
That's clever. Oh, that's a nice touch.
I'm a trained professional. I can say this is actually the first time I tried to do it this way. I'll do this, and then for Q&A we can come back. but I assume you can see it all. This is the super cool logo that I built for the program. It's a mashup of Apollo 11 and Embry-Riddle. Unfortunately, the people at Embry-Riddle don't allow logos, but I'm going to give it to you because I like it. And until I get in a lot of trouble, I'm going to keep using it outside of the classroom. Okay, so what I want to talk about is how we get to that state where we have an economically sustaining presence. And what that's going to require is going to be a transition from government to industry. And the way I'm thinking about it for this talk, at least, is I'm going to talk about risk sharing. It's not the only way to talk about government and industry working together, but it's kind of useful. But let me start with a little recognition. Oh, hang on, I have to do this first. No, we're still good, right?
Yes, sir, we're good.
Awesome. I wasn't sure about this part. Okay, so 53 years ago today, they didn't walk on the moon, they landed on the moon. So it says, here men from the planet Earth set foot upon the moon, July 20th, 1969 AD. We came in peace for all mankind. Well, it occurred to me it's time to edit this. So this is what I think we really need to get to.
Nice.
And that's the kind of thought that sets me, we need to make a transition from government programs to commercial programs. And so the first thing you have to understand is that every space program, I can't come up with one. I almost got one. When you talked, X-Core was as close as we got. But every space program that I can think of has some degree of public and private participation. And the way I think about it is industry has two kinds of risks. They have revenue risk and they have cost risk. And for every program, there is some degree of government sharing of these risks. Okay, that's just a definitional thing. But what I'm talking about is how do you transition from early lunar programs where the government is going to be taking all of the revenue risk, because right now the only entity paying for missions to the moon is the government, whether it's the Chinese government, the American government, whomever. They're paying for it, so that's the revenue risk. And industry is now taking on, with CLIPS, a lot of cost risk. Some would argue maybe too much cost risk, but they're taking on cost risk. That's not a bad thing if the cost risk is manageable. And I think in some programs, the cost risk can be unmanageable. Okay, so let's keep going here. Here's what we have. This is my favorite chart, the chasm of risk. So somehow or another, we believe, and I believe, in a future in which lunar resources have revolutionized space travel. You know, for 60 years, I guess we're at now, we have been trying to solve the problem of launch from Earth. My message is we don't solve the problem of launching from Earth through reusability. We will solve the problem of launching from Earth by launching from the moon, because the moon is a much more efficient place to launch large bits of mass. So if you can get your propellant from the moon, if you can get the material you need for large structural things like space-based solar power from the moon, you will revolutionize how we do space. And we're making progress on a lot of these different fronts. So it's reasonable to think about getting from that chasm of risk of government with money to actually getting to the commercial future. So the question is, how do we do that? So this is something that Rob Mueller gave me, and you probably can't read the details, but here it is. This is one of the first things that I've seen that's actually a roadmap. Mostly when we think about roadmaps in the technical community, it's a straight line. It's a straight line with a bunch of technologies we develop and sequence. You do not need a map for that. All you need is a gas gauge and a speedometer. This is a roadmap, because if you pick one of these things, let's just say you find volatiles in lava tubes and caves, well, you have a completely different lunar program than if you find those volatiles at the poles, at the permanently shadowed regions. Right. So it actually gives you, if you pick one of these, you're going to pick a different one of these, and you're going to pick a different one of these. Technically, we kind of understand what the roadmap is, and that's a good thing. But what you realize in looking at something like this is there's a huge amount of risk technically, even though we kind of understand it. So let's talk about how government and industry have worked together to share risk. NASA has been sort of on the cutting edge, but they really weren't the first one. So let's go and look at some programs. So this is a real simple risk matrix. This is government risk. This is industry risk. You could probably quantify it in terms of dollars, would be a really good way. And I haven't separated it out between what would be revenue risk and cost risk. You could do that. But so let's just look at it. A series of programs. I'm going to start with the X-33. The X-33 that you're all familiar with, we're going to do a single stage to orbit launch vehicle, which has always been the holy grail of the launch community. This was just going to be suborbital. I think that NASA put in about $1 billion and Lockheed was going to put in the rest. They got a little way down the road and they realized it wasn't going to work for a variety of technical reasons. And I think they finally realized it probably wasn't going to work in terms of a business case. But Lockheed took on a lot of risk at a perilous time for Lockheed, if you know something about the history. So that was a case where I think industry took on a lot of risk. And the thing about industry, I mean, look, I was an executive contributing to some of these decisions. We will take on risk, sometimes irrational risk. And I think a great program to discuss is the EELV, which some of us lived through painfully. I came in at the very tail end of it, but it was still painful. So in the EELV program, industry bought into all the risk because at the time, remember, we were going to darken the sky with satellites from Deledesic and Iridium and everyone else. And so industry was more than happy to build launch vehicles on their own nickel. The government provided 2 contractors with $500 million each, and they were going to do the rest. And Boeing and Lockheed spent, well, let's put it this way. Boeing wrote down about $3 billion, about $2.5 billion, I'm sorry. And that's shareholder money. That's a lot of money to write off, even for a company the size of Boeing. Industry took on way too much risk. And industry was going to get out of the program. They said, look, you don't make up a loss-leading program through volume. Actually, ironically, you kind of do. But so they restructured the program. And they restructured a program in such a way that the government took on all the risk. And Boeing and Lockheed, ultimately, they combined into ULA, were sitting pretty fat and happy. And they were making decent margins. It was, I will argue, the most profitable launch program that has ever been. It may be the only profitable launch program that has ever been, but it was good. But because government was taking on too much risk, they took a lot of heat for this program. And ultimately, you'll see as we get a little further in time, that had to shift. So let's talk about COTS. COTS was the time we got it right. We did. We really did a great job of balancing risk between government and industry. And that went to CRS, and industry took on a little bit more risk there. COTS, CRS are working pretty well. I mean, you can still argue sort of about efficiency and things like that, but I think contractors are happy. I think the government's happy. We're getting stuff to the space station. It's working. We're trying to transfer that model to CRS, and I argue that industry is taking on more risk there, and we're kind of seeing it because it's a fixed price contract. Even SpaceX was at least 2, I think 3 years late to market. And when you're late, you don't get rid of the people that are working on the program. You still have to pay for them. It means that's eating into your profits. I don't know if SpaceX is profitable or not on this program. I know Boeing isn't, right? We know they've already written off, I think it was $400 million against this program. So that hasn't worked out too well because we got the risk balance wrong. And I don't know, we'll see how long Boeing stays in the business after NASA isn't buying enough launches.
Right.
So let's talk about CLIPS. CLIPS is really interesting. CLIPS is interesting because normally I would put the industry risk way up here, but because most of the companies that are involved in CLIPS were already involved in the Google Lunar X Prize, developing design systems, developing a workforce. You know, the people that left Moon Express went to work. I don't know how many of them went to Intuitive Machines, but we were working together when I left. But But there was a workforce of people who understood something about building cost-efficient lunar landers. And so the industry risk wasn't that great. The real question now is what's going to happen when we start talking about the kinds of risk we're going to get involved in when we get to these big programs we're talking about in the future. So when we talk about doing real lunar operations, mining the moon, processing ice, regolith, or things like that, we're talking about tens, probably hundreds of billions of dollars. So the risks are going to be out here. We want to figure out a way to get that, a nice balance of risk. But the truth is, we'll probably bounce around because this isn't going to be just one program. It's going to be a whole series of programs, and we'll be bouncing around. Hopefully we get it right. But that's not going to be easy. So let me talk about government and industry risk. And sometimes, a lot of times, in fact, government and industry have entirely different perceptions of risk and different solutions to risk. And that's the challenge for us. So here we have Luna Locks, we'll call that industry in general, and we have NASA over here. I'm just going to go through a few risks that are on the non-technical side, because I think these are really going to be the source of challenges, because ultimately, most, if not all, technical risks transfer into economic risks. So let's look at it. So industry has a risk, a very traditional risk that they always face. Development cost exceed plan. So what does industry want to do that? They want government funded development. Okay, let's look at the government side. Government has a similar risk. Development costs exceed plan. What's their solution? Industry shares investment. And so right now, we've got a clear tension between government interest and industry interest. Let's look at another one. The risk is insufficient demand. And so what industry wants? They want sole source and anchor tendency. Similar risk, uncertain supply. They want multiple suppliers and competition. So what works for one side doesn't work for the other side. And you see this in other areas. When you talk about operational cost exceeding plan, you would like to have government providing, the industry wants government to provide the infrastructure, and government wants industry to pay them for it. And then finally, you've got financing. Industry wants government loan guarantees. Government doesn't want the political risk of government loan guarantees. So you can see we have these kinds of challenges. I'm not saying these things aren't resolvable, but you have to understand that both sides are coming into this with legitimate interests and legitimate positions. And if we do this, we're not going to get through it. We obviously everybody needs to be happy and go off into the sunset, right? So how is this going to happen? I think we need to start a conversation that includes government, it includes industry, it includes finance, and it includes the technologists, whether the technologists are in industry. But those are 4 different risk streams. And we have to talk about it and understand each other's risks if we're really going to be successful and get through this. Because as much as we love to talk about POTS, and we think CLIPS is doing great right now, we don't have a really great track record in this stuff. So that is my story, and I'm sticking to it for now, at least. And the question to all of you is, what's wrong with this picture? I'll tell you what's wrong with it. He's drinking a Carlsberg. No one would go to the moon and drink a Carlsberg. Okay, so let me get out of this mode and back into what I think.
That's a pretty dynamic setup you got there, buddy. Thank you very much, sir.
I'm a trained. Listen, it's just simply, this is the kind of magic you'll see involved in our program at Embry-Riddle.
Good plug. By the way, you definitely need to put that link in the chat here so that we can broadcast it.
Oh, okay.
You know, we've got 2 YouTube channels going beyond this, so I want to make sure we broadcast that a little bit.
All right.
That was fantastic. There was some new stuff in there. I really did like the comparisons of the various programs about, you know, where on that spectrum of risk. I thought that was really interesting. All right. So
do we have questions? No.
Not yet. We come out of this. Apollo traditional. This is the way it's done. This is the way it's always done. We're moving to the Artemis, where kind of all bets are off, right? We're definitely not doing it the way we did during the Apollo program. So, given the model that you just showed us, let's talk about what happens next.
Yeah, well, I think so. I think what happens next is ideally you would have people getting together, as I suggest, to start a strategic dialogue and understanding risk as you start thinking about what the roadmap is going forward, so that we don't get way out of balance. And I think it would be, you got to figure out how to get the right people around and how to get them around the table where you need them to actually talk about what their specific interests are, but you want them to listen to what the other side's concerns really are. And I think, people like Jim Bridenstine got it, right? He got it. He understood the risk. But it's sort of amazing. How many people I've had conversations like this with, and NASA who said, well, we got a great deal out of this. Why should we complain? It's good for us. And it is for the short term, but it's not for the long term. And we have never taken on something as sociologically complex as going to the moon, as going back to the moon and creating an economically self-sustaining presence there.
You mentioned Bronstein. That's the second time it's come up in 20 minutes. From an industry perspective, we were originally kind of horrified by him.
Yeah.
His background and his voting record. We're like, this is the new NASA administrator. Like we were not, as an industry pro, most of us were pretty surprised. And gosh, what a turnaround. We were all wrong about him.
There were things that he was very good at and things that, there is no one person who's capable of running all of NASA.
No, it's a complicated beast for sure. So hats off to that. That was a surprise to the rest of the industry.
But the point is, it's just like I said, there is no one person who can understand the complexity of trying to design a transition from a government to an industry program. Yeah. There's something that's as complex as this.
Yeah,
you're handing over the entire planet, basically.
You are, yeah. Hats off to the folks that preceded him that kind of risked their careers to start that process, but it would have been really easy to just stop the commercialization in its tracks and instead kept.
I get in trouble sometimes. In fact, my students call me with some encouragement by me, the cosmic curmudgeon. But we are on a pathway. We're not there yet. We are on a pathway, and we've decided we're going to take that turn, but we're entirely capable of screwing it up. Remember, this is the third time we've had a commercial wave.
Right. Yeah.
Right.
Yeah.
And they're ultimately, when I go back and I think about the question, what's different now? It's not so much technology. It's not so much there are things that are happening economically, but I put them in a different basket. There are institutional things that are happening, institutional things in terms of the capital structure. So when we did the last flailing attempt at constellations, everything was funded by corporate debt, and it was there was a little bit of venture capital in it. And if you look at it today, we've got venture capital, we've got institutional debt, we've got private equity investing in some of this stuff. And so it's really robust. I look at what's the de-SPACification we're seeing, and it's horrific.
Right.
But I also look at it, and I look at it and go, well, you know what? Rocket Labs came out of this SPAC, whether it flattens or not, with $700 million or something like that of real cash.
Right.
And so you've got to be smart with that cash. But it's a good thing. But the next I think the next 5 years are going to be they're going to be challenging. There's going to be a lot of shakeouts. But what we're talking about with the moon is so far out there. Honestly, I don't worry about the sort of wave we're going to see right now. It's barely going to get to our ankles when you're talking about moon stuff, because we're so early. And I think because, the China thing that I was talking with Laura about, the compelling reason to go to the moon isn't going away. And it's not just commerce, it's certainly not tourism, but there will be a compelling reason for the United States to be there geopolitically. And it's not about beating the Chinese to the moon. It's about owning the moon. So I shouldn't say that. I'm going to get flamed for that. I don't care anymore, right? I'm an academic.
There's a difference between own and control. And I think that's where the nuance of the Artemis Accords is just so smart. We do have a couple questions. I'm going to, sir, with all due respect, we have a very hard stop at the top of the hour. So,
okay.
So one is always kind of the first question's always a little iffy. Are you willing to share your email address? And what I would recommend is a LinkedIn profile, and then.
No, I'm happy to share my address.
Okay, cool. All right, so definitely put that in the chat then.
Okay, I can do that right now. Okay. Do you have it? You've got just put my Embry-Riddle one.
Yeah, okay. I will do that in a minute then. I don't want to stop the flow of the conversation. So I'll do that because I have that. Next, so that was from Michael Allen, and then from Doug Plata. Would dramatically reduced costs if Starship is successful, reduce risk for both government and industry?
Sure, of course. I mean, that's easy. That's the easy question. The question I have with Starship is, if I had hair, I'd be scratching it, because it is so far outside of our zone of understanding of the economics of space. I mean, think about a few things. If they launch in 50 times a year, in 3 years, they will have launched as much as humanity has launched since the beginning of time. If there is kind of a base launch, a demand, it's like 430 tons or something like that. If you strip away the constellations, because the constellations are just something different. We'll just say that for the moment. That's 2 Starship launches. And if you take out China, right? Because of that 400, some of it's going to be launched by China, and so Starship's not going to launch that. And so these numbers get to be crazy. And what we have learned the hard way in the launch business is anybody can make money if they're launching 50 times a year. Nobody can make money if they're launching 2 times a year. Right. And so that's the challenge, because SpaceX has still got, bless us, 9,500 people, and you got to pay for them. Right. And so that you reduce the number of launches, you just divide by a lower divisor. And so that's the part of Starship that I don't get, where it makes sense. Look, we're spending something between $3.5 and $4 billion on stuff that Starship could replace, at least that much. And so it makes a whole lot more sense to me long term that if you have something like Starship that really works, that, okay, so that it takes over that part of the market, but that's still, maybe instead of 1 launch every other year, we can do 2 launches a year. It doesn't fundamentally change things. So I don't know. I mean, there's another thing that's kind of an interest, that the notion, of course, the economists will say, well, as the price comes down, demand goes up. Right. Now, we tried that once, right? When the Falcon 9 first came out, they came in, and the going price was, call it 140 million or something a launch to go to GEO. And they came in half of that number. And we have historically had 20 GEO launches. Before SpaceX came in, we had 20 GEO launches. After SpaceX came in, we had 20 GEO launches. So it didn't change that. One could argue that SpaceX coming in at a lower price has enabled the constellations. And that may be true to some extent, but the constellations are a completely different discussion it's not driven by the launch, it's driven by the telecom market. And there are, I just put together a course on the telecom market. We are the gnat's pimple. in that market.
Yeah, it's staggering numbers.
But it's a lousy market. It's not. It's a market in which you have explosive demand and you have implosive price, and the implosion is happening faster than the explosion. So the net market value is going down, in spite of the fact that the demand for data is exploding. And it's not a good place to come into with $100 billion investment.
Wow.
I don't know.
That's interesting. By the way, I'm writing a paper on the Starship Singularity, so I'm definitely going to use your quote in that paper. So
okay. I'm happy to talk. I got, I'm going to get flamed by everybody anyway. So
no, it's brilliant. It's brilliant. The chair of the Moon Society asked a question, Philip Krum. Do you think Artemis could be used to make the next step towards economic? Well, I'm reading this wrong. Do you think Artemis could be used to make the next step towards economic sustainability? So can Artemis become economically sustainable?
Well, it's not
sustainable earlier.
It's what Artemis will support economic development. I think the principles embodied in Artemis, particularly the right to use lunar resources, is critical and pretty essential to developing a space-based economy that depends on lunar resources. So in that sense, it's absolutely essential. But it's just the foundation, and it's a series of government accords, and it should remain a series of government accords. And maybe, maybe if you needed real regulatory functions to divvy up or manage the lunar traffic, given the kind of problems we talked about, with safety zones or things like that, just in divvying up the lunar real estate, maybe it ends up looking a little bit like an ITU kind of thing, so that we're not just, it's not just California in 1848, you get a claim and a shotgun and it's all yours. And maybe Artemis can evolve to doing something like that. And we know the ITU works pretty well, but it works well because there is a requirement, and you do sort of have a similar requirement on the moon in that you can't have two people in the same place at the same time, or they'll kill each other with rocks.
There's a lot of people on this call that don't know what the International Telecommunications Union is. So tell what they do well, so that.
Okay, so you all know that two frequencies can't transmit to the same place at the same time and the same frequency. So you have to regulate it. So there is a technical necessity of regulation. And the ITU is a body that was created at the UN, but it expressly involves not just governments, but industry as full members. And they negotiate every 5 years of work. They get together and negotiate spectrum allocation, but they continue to do these kind of things. And it works pretty well.
It does. Yeah. Okay, wrapping up here, Laura's got the last question. Do you worry about investors and other stakeholders being scared away due to failure or poorer performance?
Yeah, of course I do. But I mean, getting scared away due to poor performance is, in a sense, I'm going to shed crocodile tears for them, because investors need to do better due diligence. I mean, honestly, look at the small launch market and how many billions of dollars are being thrown at a market that just doesn't make sense. And it's one of those things where I go, what were you thinking? And so I see some of the investor projections and things that go out there that are supposed to go to the investment community, and my students quote them back to me, and I just go, what's behind those numbers?
Right.
I mean, Morgan Stanley.
Yeah. What are they saying? They're like, it's a trillion X or 4 trillion X or something like that.
It's $1 trillion economy, but almost half of that is secondary effects.
We're going to have a whole conference the end of August that the whole topic is the finance and capitalization of space. I think it's going to be really interesting because nobody is talking about this stuff, and it's kind of voodoo.
Fight me if you want to fight.
I'm bringing you, for sure I am. I was self-serving. I was watching your presentation. I'm like, yep, I need that slide on my next event. So yeah,
anything you want. I have done a lot of work looking, I won't say analyze, I will say analyzing markets. What are good markets? What are bad markets? There are markets that I love. I love remote sensing. I'm not totally sure of everything, but I think there's some magic that can happen when you've got 20 different providers out there providing different streams of data, and people on the ground start figuring out how to pull that data together into products that solve real problems on Earth. I think magic is going to happen there. I really do. And there are real markets there.
Yeah, I do too. Okay, 2 minutes left. All right, you used to be involved with Moon Express. If you were building a commercial company to go to the moon, what would you do? What's the first thing that you would do? And assume there's cash behind it.
Yeah, so what I would do, the first thing I would do is get a really, really good understanding of the roadmap and what point I really want to enter and how I manage to survive until the real market happens, right? Because right now we're dinking around with stuff. Government, NASA, the numbers are tiny. I forgot what the number is, but you're talking hundreds of millions, and that's trivial, right? And so, but at some point, we will know when it's really going to happen. And you want to know that before it happens. And don't go to the investors and get 100 million or 500 million of investment that you're going to have to figure out how to pay down during a lean period before the real growth happens. But I think the first thing I would do is figure out how to get really smart and what a plan for rapid acceleration when the flag goes up looks like.
Okay, I'm going to call that a kind of a vague answer. So you don't have you wouldn't set up space hotels, you wouldn't set up mining. What you're saying is understand the foundation first.
Right. I wouldn't set up space hotels until there was rapid, affordable, reliable transportation. And I can probably build a hotel faster than somebody can actually come up with the transportation that's going to get the tourists there.
That's
what I think.
That's a useful point. All right, sir. Always fascinating. I put down August 30th and 31st because I'm definitely calling you for that. All right.
I'm on. That sounds like a lot of fun.
Yeah, it's so good. Thanks a lot, sir. Appreciate it. Bye-bye.
All right. Bye-bye.
All right. We are on a very specific clock because we are going to celebrate walking on the moon. Dr. Nicholas.
Thank you.
Hey, how are you, sir?
Good, thank you.
Great.
How are you?
Great. I'm having a great day today. Thanks a lot for helping make this happen. Your bio also is a little sparse, and I know you did that on purpose, so I want you to fill it out. But what I have is Dr. Nicholas Jobstrat has recently bought an old schoolhouse that he has started to convert into a moon-based validator. And that's cool, and I'm super excited about that, but I need you to tell us a little bit more about you, sir.
Okay, I got a PhD in structural mechanics of metals at high temperature, and I worked for aerospace companies most of my life. Currently, I have a day job working on turbines still, but these are wind turbines now, so that's a different temperature regime.
Cool. Neat.
Is that better?
Yeah, it is a little bit more. Thanks a lot. Appreciate it. All right. So the rest of this day is really on you, sir. Take us through this celebration that we're going to have.
Yep. I'll start with a bit of a background, and I'll get to a bit of some footage, simulated footage of the lunar landing, and I have an alarm clock to tell me when to start that, because I will probably ramble too much before that. So I will go to my PowerPoint there. Let's see. And then I should actually share something as well. And now I hope you see my moon base.
Thank you. Yep.
Good.
By the way, love that picture. That's clever.
Yeah, that is the actual school I have bought, and it's the way it's intended to end up, obviously. This is what it looks like now. Well, actually not now. The snow has melted eventually, but when I got there in April, it was like that. There was a fair bit of discussion of self-sustainability before, so I will add my definition of self-sustainable. It would survive if abandoned, i.e. If Earth decides not to support that moon base anymore, the guys there should survive. Wow. And what I want to do, in contrast to most other analogs, is that I'm going not forward from what do you do when you land, but I want to go backward and study what do you need in order to make it self-sustainable. And then once I have a kind of a end of the roadmap, then I build the roadmap backwards, which is a valid way of doing roadmaps, but it's not the usual one. So in order to talk about the lunar landing, I have made a kind of inverse logarithmic timeline, starting at the right with the Apollo landing and then going backwards to the first reference I found on, I will turn it right date. To the first I found, which was 160. It is kind of logarithmic, so it's much larger steps in the beginning. Starting at 160 ad domini, Luciano Samosata published a true story. Well, he called it a true story, in which they reached the moon with a boat with 50 rowers carried away by a terrible wind. At about the same time, there was another mention of a moon travel by Antonius Diogenes, The Wonders Beyond Thule. And then it became quiet for over 1,000 years. So quiet, actually, that in 1110, there was an Anglo-Saxon scribe whose name has been lost, who wrote something called Peterborough Chronicle, mentioning that the moon disappeared completely from the evening to the morning. And it came back just before the morning. It has been theorized recently that that was because of a series of volcanic eruptions that hit the moon, but somehow not most of the stars. Then, of course, Dante came with the Divine Comedy, and part of their travel was to the moon. They arrived there through gusts of wind and power, which sounds pretty much like a rocket engine to me. So he was quite good at predictions there. We also have Johannes Kepler, who okay, where did I do that? Oh, never mind. He published a story called Somnium. It's a science fiction story, actually. Of course, Kepler was the one who did orbits and stuff like that. But in his story Somnium, the protagonists got to the moon with the help of a demon summoned by his mother. And that's after he came back from having been sold as slave by his mother when they got upset about something. 1610, Galileo Galilei did not publish science fiction, as far as I'm aware, but he looked at the moon through a telescope. 1938, there was another suggestion by Francis Godwin, The Man in the Moon, or a discourse of a voyage thither by Domenico Gonzalez, Thy Speedy Messenger. And there is a rendering of his invention here. It was a machine carried by 25 geese, I think it was. Yeah. 1645, Michael Florent van Langren made the first map of the moon, and 1753, Roger Joseph Boskowitz proved that the moon has no atmosphere. Which is pretty early. I would have thought that would be a bit later. 1824, Franz von Gruithuysen suggested that craters were formed by meteors. In 1835, another suggestion on how to get there by Edgar Allan Poe, the unparalleled adventure of one Hans Pfahl, and he got there by balloon. And then I should do the next. And then, of course, we have the most famous one, which is Jules Verne, From the Earth to the Moon. And of course, he enlisted the Baltimore Cannon Club. The picture here is possibly unrelated. It's from a film by George Miel in 1900, so a bit later. 1897, Konstantin Tsiolkovsky published science fiction on the moon. He wrote a lot of science fiction, and On the Moon is very fanciful, but with a lot of still valid data about how life on the moon would appear. And then H.G. Wells, the first man on the moon, he also had a new device for getting there. He smeared an anti-gravity paste on the outside of the spacecraft. 1903, Konstantin Tsiolkovsky wrote a scientific paper, which his title was The Exploration of Cosmic Space by Means of Reaction Devices. So that is arguably the first time a rocket engine is actually mentioned, undescribed scientifically. 1929, they started making films out of this with a German director, Frau in Mont, and they were getting there by rocket. Then the war happened, and during the war, I haven't actually found anything, but I have heard mention that there were plans by the US Army to establish a base on the moon. There is no air and no water on the moon, so it has to be the Army. And after the war, there were kind of a race to get films out. In 1950, there were two films. Destination Moon started marketing, and then rocket ship XM, which XM standing for Expedition Moon, beat them with a much lower budget and reached box office faster. Apparently, at the same time, Hergé in Belgium let Tintin go to Destination Moon with the same title, also by rocket, and the very classical red and white one. And there was another film about Project Moonbase. Apparently, the Soviets picked up on that, and 1957, Sputnik 1 was the first to leave, to get in orbit. And Luna 2 reached the moon in 1959 and impacted near the Autolycus crater. 1962, you Americans picked up on that, and John F. Kennedy decided that we should, well, it was a bit earlier he decided, but he held a speech in 1962 when I was born, and said that we were going to go to the moon and other stuff because they are hard and not easy. Soviet still in the lead in 1966, made the first soft landing and also the first artificial lunar satellite, Luna 10, which I tried briefly to find out what's happened to it. It went silent pretty fast, obviously being battery driven, but I think it's still in orbit. Then 1967, NASA picked up and also sent the lunar orbiter, and apparently made the first complete photo mapping of the moon. Luna 9, by the way, on the first soft landing, maybe that was the name. It took 9 photos and sent back to Earth before it ran out of battery. And then, of course, NASA continued with Apollo 8 in 1968 and the first crewed moon flight. And 1969, as we all know, that's what we're celebrating now. It's the first lunar landing. And that should be in roughly 4 minutes. So I should swap to showing the movie. That wasn't easy. Oh, sorry, wrong. Oops, there. That's a good timing. Raise your arm if you don't hear anything, because there should be a. Oops.
No, I don't hear anything.
I did the sharing wrong, and then we will be delayed. Let's see. So the share screen. There we go.
Feet still looking very good.
We can go from there.
We're seeing your
1202, we copy
PowerPoint.
it. 35 degrees.
Do you hear now?
We hear it, but
degrees,
we're only
750,
seeing the PowerPoint.
Coming down to 23.
We're not seeing
700
the
feet,
video.
21 down.
There
33
you
degrees.
go. There's the picture. It wasn't.
No. We're not seeing the video. We're hearing the video, but we're not seeing it.
540 feet down at
That's
30.
really
down at 15.
odd.
They're 400 feet down at 9.
Still hearing it, but now we're seeing a
Take
blank.
forward.
Now we got it. Now we got it.
Okay.
10 and 50 feet down at 4.
I'll get back to the start actually.
1400 feet, still
We'll be
looking
a
very good.
minute later, but never mind.
Roger, 1202, we copy it. 35 degrees. 35 degrees. 750, coming down to 23. 700 feet, 21 down. 33 degrees. 100 feet down at 19. 540 feet down at 30. Down at 15.
And you don't want to land there.
They're 400 feet down at 9. Gate forward. 10 and 50 feet down at 4. 33 and a half down. They're pegged on horizontal velocity. 300 feet down, 3.5. 47 forward. Put up. Down 1.5 down. 70. Epic shadow out there. 50 down at 2.5. 19 forward. Altitude, velocity, light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. 9 forward. Good. 120 feet. 100 feet, 3.5 down, 9 forward. 5%. 185. Okay, 75 feet. Guys looking good, down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5. Forward. Forward.
There is the landing stage already in place, obviously, since the
down,
footage
2.5.
is late.
Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. 20, down a half. 30 seconds. Forward. Just good. Okay. Contact light. Okay, engine stop. ACA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
That will never get old. Thank you for sharing that.
It was good, very good timing, actually. So it was good that I had to restart a bit. Okay, so now what happens is that we're going to sleep for 6 hours and then we're going to get out on the moon. I thought I'd skip the sleeping bit and just have a toast to the moon, or maybe toast back to the moon or forward to the moon, or whatever you prefer there.
I like
and then I will make footprints in Lunar Regolith. I'll get back to that. Cheers.
Cheers.
So now I'll start briefly share screen again, and then I will okay, so back to school building, and this is pre-launch, and I call it Lapträsk 2022 with an obvious nod to an old TV series, Lapträsk 2022 on the moon. Now there are two problems here. The obvious one is that I don't actually have a moon base, I have a schoolhouse, and the other one is that I don't have a moon surface to be on. The second one I have, well, the first one is the aim of the project. I'm going to make this into, well, the interior of it into a moon base, and the moon surface. Well, I have been at this for a while. 13 years ago, I got a gift from Shimizu Corporation, their space and robotics project, which was a bucket of 25 kilo of lunar regolith simulant. So I'm going to use that to make footprints. Thank you, Shimizu. There is one I tried earlier. Don't do this at home. Let's see. Try to escape and stop sharing. And I will. There we go. We have oven-proof tray filled with lunar regolith and a foot.
The first step at your new lunar analog facility.
Exactly. A small step for a man and a big step for Lapträsk.
That's awesome. Congratulations for opening your new facility. So tell us how you feel, and tell us about what's going to happen with this new facility.
I'm feeling good, and well, it is a good place to have a moon base. It is quite the right size, actually. I'll get back to sharing screen, I think, because I have a picture of it. I want to share that picture, and then I want to there, and then there. So there is an aerial photo of the school, and it is an old school building with classrooms, which is pretty much the correct size for doing different process experiments. So essentially what I plan to do is to allocate one classroom for each type of process that will be in a moon base from mining. I have actually found there is an unfurnished room in the basement where there is a piece of bedrock, so I can just, well, a piece of bedrock where there is bedrock on the floor. Part of the floor is bedrock, so there I can start a mine and start simple mining experiments. There are good windows, so I will also do growth experiments. Essentially, I would like to do them as with artificial light, because I think it will be difficult in a moon base to run to get the sunlight in. I consider it necessary for a moon base to be a fair bit underground as protection for meteorites and radiation. So yeah, that's about it actually, and I don't have that much more, except I can show you roughly where this one is, where I am right now, rather than this one is, because I'm sitting in here.
So that's a big facility, right? So earlier today we talked with Terry about his site, and by the way, we're still mostly looking at your footprint. Yeah, we talked to Terry with his 4-person facility, and Celine was talking about their proposed facility that would grow to hundreds of people, and then Terry showed another one that might have 40 people. So what are you looking at? Like, what are you going to be able to test? This doesn't look like the HAB sites that other people are doing. So what are the benefits? What are the drawbacks to this?
Good questions. Several of them. I'll try to answer without picking one at a time. The main difference, I think, between this and I would say all other analogs that I've seen is that I aim at going backwards. So I aim at looking at pieces of what will be needed for a quite large scale facility. So I have as a ground rule that I can use whatever I want, but I need to be able to make a copy of it, or a replacement for it rather. I mean, I can use a plastic spade. Well, I wouldn't want to do that, but I could use something made of plastic, but then I don't have to remake it in plastic because plastic finds a lot of volatiles. So I might prefer to make it an aluminium instead, but the same function. So that's one main importance. But another question you asked, what kind of, how big is it? The house on 3 floors, basement, ground floor and first floor, is a total of roughly 1,500 square meters. Add a 0 if you want square foot. And how many people it could hold, I intend to run it partially at the kind of youth hostel in order to have the possibility to get people in to help me build it. I'm a bit too few.
I think that's a really interesting idea, right? Because then it kind of becomes financially sustaining as well as bringing attention to what you're doing.
Yeah.
Yeah.
And the physics, the gym is that's the house on the right side here. That's the gymnasium, and I intend to make that into a combined conference hall and with a bit of outdoor on the moon experiment facility, if you like. Put a pile of sand in the corner, and then you can play with robots there if you want. Not my main aim, but you need to do something outside, and it could be of interest. For example, one thing that I think will by necessity happen outside is solar power generation. The only real alternative to photovoltaics, as I see it, is nuclear power. And to make a nuclear power plant in a small town, resources, I think, is way more difficult than to make photovoltaics. So the conference hall will hold 100 to 150 people. Most of the process steps will be much smaller. If I make food for one family, I think I would be very satisfied with that.
Nice.
In the greenhouse.
Yeah. Right. Like that would be more than NASA's been able to do for 20 years at the ISS. So feed one person, grow to being feed one family, and then grow to whatever else, right?
Yeah, I'll start by growing salad so I can have that once in a while.
Right.
And fish. So I'm aiming for an aquaponics system for the growth part.
And you're going to talk more about this on Saturday, right?
Yeah, I am.
Okay, so I don't want to like pull all of that from this. I want to make sure that people know that they're coming back Saturday. We have a great lineup on Saturday as well. And I'm going to start bringing in were you done with this piece?
Yeah.
Okay.
Thank you.
Yeah, I don't want to. I really want to.
I was done, and yeah, I can go from showing my footprint to showing myself as well.
Well, I'm excited about the footprint. I'm excited about opening. And forgive me if I pronounce this wrong. Lop. Oh my gosh! Give it to me again. Lapträsk 2022. I love it.
Lapp is another name for the natives of northern Sweden, and Träsk in southern Sweden that means swamp, but in northern Sweden it means lake.
All right, a lake.
So it's the lake of the Sami.
Nice. That's brilliant.
Roughly.
So it's open for business now, right? Like I mean, I know that you've got some permits. I know you had some troubles before with that, but you're basically ready to start. Yes.
Yes, I kind of have started. I haven't actually done much, and I'm mainly busy getting the west part, left one on the picture that I'm gonna have as my house. So, and in order to be allowed to live here, I have to follow the procedure and make that into a dwelling first.
Yeah. You're there now? Are you there?
I'm here now. Yep.
Okay.
I'm in that part.
Okay. All right. Fantastic. Dr. Jobstrat, really excited about your near future. We're not talking decades away. We're talking about weeks and months as this thing unfolds. So we'll learn more about it on Saturday. And with that, we're gonna close out our program. Yes?
Yep.
All right. Let's bring on the other folks from the Moon Society here. We're all just gonna do a short goodbye. Let me bring on. Before we do, I'm gonna talk a little bit about Saturday. Okay, good. I thought one of them wasn't coming on board. All right, let me check. So this is kind of the wrap up for our day. Really glad for everybody who was here. We're between the Moon Society's partnership and the science fiction community Axonar that joined us. This has been great to have everybody kind of looking at the future. Where are we going? Today was a lot about level setting, about where are we, where did we come from, And then Saturday, we're going to spend a lot of time talking about where we're going. We wanted to have this event broken into two parts, one to specifically celebrate this historic moment, this historic day. So Dr. Jobstrat, really happy that we had the toast to first landing on the moon, a pretty exciting moment. But where we go from here, right? So we've got the Artemis program where we learned that Capstone has already left for orbits near the moon, a halo rectilinear orbit. We know that after today, we know that the first Artemis 1 mission is going the end of August, early September. As Laura said, that's hurricane season. So who thinks we're going to launch there is anybody's guess. But fingers crossed, this is the beginning of a whole new era of humanity. And I don't think that is hyperbole, that we're at the beginning of a new era of humanity. And it's amazing that this is happening, right? And I think that the Moon Society is going to play a role in this as we start going back to the moon for real. So next week, on Saturday, on the 23rd, we're going to use the same link that you used to get here. The Moon Society will send out another invitation, but we're going to use all the same information. And what are we going to talk about? We're going to talk about living on the moon, how hard it is and what we're kind of hoping to accomplish. We're going to talk about what I've been saying for a while is maybe one of the holy grails in space. We're going to talk with Dr. Edgar Elbrick to describe what's it take to have babies in space. We're a long ways away from that, but unless we figure out how to have children off world, off Earth, wherever we go in the solar system, all we're doing is camping. We've been on the International Space Station for 20 years, but we're just camping there, right? We're going to go back to the moon. Unless we can figure out how to have children, we're just camping. We're going to go on visits that go back and come back home. We're going to talk a lot about lunar simulants. And that's really important. That's one of the core elements of science to figure out what it is that we're working with. Everybody talks about in situ resource utilization, but if we don't know what we're working with, we can't really start the industrialization processes on the moon. So simulants are a necessary precursor. We're going to talk about building a circular economy both on the moon and Earth. I am not entirely sure what we're going to talk about on that topic, but so I'm curious to see where Anderson goes with that. We're going to talk about off-Earth agriculture and growing stuff. We already heard a little bit from Terry Trevino. He gave us a bit of a teaser today, but we're going to learn a lot more about how do we build a self-sufficient environment. Dr. Jobstrat just a moment ago claimed that sustainability was, if it was cut off from its primary source, would it be okay? Are the people there, are the facilities there going to be self-sufficient? That is a completely different definition than the former NASA administrator was using. So I like Nicholas's version better because that means self-sufficient from Earth, which I think is going to be a long ways and very difficult. But I like that version because I think it's a more optimistic version. We're going to spend some time talking, like we did earlier today, like Philip did earlier today, about the survey. I'm going to post the survey one more time in all the places so folks that came in late can see that. That's a really important tool that the Moon Society is going to use to figure out what direction they take going forward. So it's going to be an interesting day. Lunar algae, having babies, lunar simulants, and analog sites. So I'm really looking forward to it. There is there is a chance that we're going to have some rovers in here, but there's some communication problems. So I'm not sure whether we're going to have rovers talks or not. Hate to have that kind of ambiguity, but that's where we are. All right, so with that, I'm going to sign off and I'm going to give closing comments to our beloved Moon Society leadership. So I'm going to start with Nicholas, because you were just speaking, bring you over to Michael Mealing, bring you over to Dana, and then to Philip. So with that, I'm going to be quiet and the show is yours. Thanks a lot, gentlemen, for all of your support for this event.
Thank you, Michael. Yeah, but
sorry, I have to interrupt one thing. I have to thank my team. It's really important to me that I thank my team, because this stuff does not happen without them. So Fabio and Yusuf, Joey, Youngin, Gion just left. She was an intern from Korea for 4 months. Youngin is leaving on Saturday, so she's sticking around for the last day, and then she's going back to Korea. So Leah and David, all my team, this stuff could not happen without y'all, so I'm always grateful. And finally, to the folks that are listening, both on this channel from the Moon Society folks and on the channels on YouTube, our Liftport channel and the Axonar channel. It doesn't matter if we're just talking to ourselves. What we really need to do is talk to everybody else. So really thankful to all of those fans and members that we do this for y'all. So with that, I'm officially out. Thank you. Sorry.
Thank you, Michael, and thanks to your team as well. And of course, everybody who has been listening. And it's exciting times we're living in. It actually looks as if the road is there. We just have to decide what to put on it so that we can get to the moon. And of course, still spend a lot of money to get there. But that's the way things are. So I'll stop there, I think. To the moon.
Thanks.
Next.
Thanks, Nick. Yes, thanks, Nicholas. So yeah, this is Michael Mealing. I'm the current president of the Moon Society, but I am in the process of stepping down. Depending on how you look at our bylaws, I think I've actually been president since maybe 2004, I think. Yeah, I came on board, back on board a few years ago to help get the society back on its feet. It's now doing a pretty good job of that with the evidence of things like this conference itself. My day job is a space technology venture capital fund. We currently have $55 million under management, and by the end of next year, we're slated to have over 200 million under management. So my day job has taken over my life, which was the intent. And so between that and my policy work on the Hill here in Washington, D.C., I'm having to step back from the society and turn it over to the rest of the teams here. And so I will not be running for president in the next election that comes up, that I'm sure somebody from the board will be discussing toward the end of the conference. But yeah, I've enjoyed my time. And I think there was some discussion of me being president emeritus, which means you're just an old fart. So that's my role. I will be the curmudgeonly old fart. But thanks, everybody, and enjoy the rest of the conference.
Dana?
Hello, I'm Dana Carson. Like I said, I've been associated with the Moon Society since it was formed. And yes, I think that the series of Lunar Development Conferences has been a very good thing that we're doing. And I hope you'll all come back Saturday for the other half of this one. And hopefully we'll see you for next year's too.
Hi, this is Philip Krum. I just wanted to thank everybody for coming to attending the conference. we genuinely appreciate your attendance here, and we look forward to hoping that you learn something new and exciting, and that's something that would get you mobilized and engaged. And I wanted to thank the members of the board. I wanted to thank for Michael for all that you've done for us, Nicholas for for your long-term support for the Moon Society, and Dana, you have been a phenomenal backbone of the club, and of the society, and we genuinely we value you are a valued member of our team. And finally, to Michael Lane and his team, we couldn't have done this without you. We do appreciate all that you guys have done for us and for the Moon Society, and we look forward to a future where we can all achieve our dreams of doing something we would like to aspire to on the moon. And from there, we look forward to building a space civilization after that. So thank everybody for attending. And again, thank you for coming.
Bye, y'all. Thank you so much to the Moon Society. And with that, we're going to close off. Thank you, everybody. And we'll see you on Saturday. All right. Bye-bye, y'all.
Great. Bye, everybody.
Bye, everybody.